Scholastic greetings again to each and everyone academic scholar in the class. Welcome again to this course, CIT392, Computer Laboratory 2. In our last class, we dealt with the introductory parts of this course, and we looked into a number of things, including programming and the evolution that went on with it. And we ended very well by tasking ourselves to go through the TMAs, the tutor marked assignments, which we have at the end of that Unit 1. I hope we all did that. We will be kicking off today's class, Unit 2, Programming in C language. Programming in C. I dare to say this is where the course actually begins. But of course, what we do in computer laboratory, beyond just the ethics, the do's and the don'ts and all of that, what we do in computer laboratory is programming. So when we begin to deal with programming, is when we begin to talk about computer laboratory and its functions itself. So I'll be kicking off programming in C and answering this first question here. What do you understand by programming? That's exactly what we dealt a lot with in Module 1. But I want to also delve into it a little. Reason because programming also exists in a couple of other fields outside IT, outside the computer world. I take, for instance, in social works, NGOs, humanitarian services, and all of that, they also use the term programming. And what does it refer to in that field? It refers to developing actionable steps to combating some problems that has been detected. Problems could include HIV/AIDS prevalence, sexual and gender-based violence prevalence, and all of that problems. So they come up with a solution. Solutions include advocacy visits to the communities where these prevalence occur, orientations and sensitization of the stakeholders, and then coming up with a strategy, possibly peer sessions and instructor-led sessions, whatever strategy they could come up with to orientate the target group that may be the perpetrators of these prevalences. Maybe the young men who are engaging in illicit sexual activities such that HIV prevalence is now high, or young boys and young men who are engaging in sexual and gender-based violence. So whatever strategies they come up with, putting all of these into actionable steps is what they also call programming. They have a solution, they put it into some steps, and then they begin to implement. When you ask them in the social field, they tell you, I am a HIV/AIDS prevalence programmer. You'll be wondering, wow. Another field, sexual and gender-based violence, will say, we are doing SGBV programming. You'll be wondering, is SGBV a programming language? But of course, it exists, programming. But here in the computer world, programming is a different ballgame. We are in our computers, we are doing some coding. There in other climes, coding does not exist in their programming. They just implement actionable steps from preconceived solutions to well-defined problems. Yes. So I would like to put some definitions across that will help us to understand each of these separately. Programming is concerned with solving problems by converting preconceived solutions into actionable steps. You can take that as a generic definition of programming from whatever fields, even across computer science. It's just a generic. It's concerned with, yes, solving problems, actionable steps from preconceived solutions, yes. But in computer science, and when we talk about computer programming, and then we can say computer programming involves encoding. The word encoding must just show up there. Encoding the actionable steps of a preconceived solution into machine comprehensible instructions for the computer to execute. Now that, my friends, is computer programming. We can go on to say computer programming is the technological process of telling a computer what to do or which tasks to perform in its own comprehensible language now, in order to solve a well-defined problem. And of course, when telling a computer what to do, it shows that you have a solution already. But no assumptions. You can as well rewrite these definitions to include the word preconceived solutions of a well-defined problem. So please take note, computer programming has the word technological, it has the word computer, it has the word encoding. But in other climes, those words may be found missing. So welcome again to Programming in C, and I trust that this course will be very interesting. We'll do the best we can to deal with this course extensively, because in the course of CIT392, we have other programming languages, and the best for us is to deal with the very first programming language in depth, such as will enable us to build on that foundation for subsequent programming languages. More so, they are closely related. From C, we go on to C++ and then Java. They are all closely related. So if we can deal with C in depth, we will just have some top-ups, some little changes, little things to see differently in other languages. So let's begin. The introductory part of C programming language is here. C programming language was originally developed by Dennis Ritchie of Bell Laboratories. Now take note of that. It's a one-man project. One-man project. Now you'll see why this is very, very important as we go on. And it was designed to run on a PDP-11. That's the name of the device. Must have been a big computer then, PDP-11, running on a Unix operating system. So one-man project, even though it's a organized laboratory, yes, but it was just him, this one man, who thought of the whole idea of, machine language being quite difficult for people to communicate in. And so the problem was already lingering in the computer world, and he picked it up. Let's see what I can do. Develop a middleman platform such that human beings don't have to communicate exactly in machine language to the computer. There just be a middleman where I can speak some language, not exactly human language, yes, and then that middleman does the translation. So we're beginning to talk about evolution away from machine language. Reading further, programming in C is a tremendous asset in those areas where you want to use assembly language. So it tells us that this was the beginning. This was about one of the first few languages that came as an assembly language, C. Assembly language, one step away from the machine language, the use of assemblers to do their translation. But don't get me wrong, today, C languages are high-level language. Of course, evolution has taken on from the first version of C, which was an assembly language, and then it has advanced and advanced. And so the C we're writing today is closer to the human language. It's a high-level language. It doesn't run on assemblers. the C of today run on compilers. But take note, it first started as an assembly language running on assemblers. So I read further, but they will rather keep it a simple to write and easy to maintain program. All of those notes there make a couple of sense when we read through, but I'll just skip and read from somewhere here. However, the time saved in coding can be tremendous, making it most desirable for many programming chores. Since C was designed essentially by one person and not by a committee, it is very usable, but not too closely. Now look at that. Not a committee of programmers, not a committee, a group of developers, but one man. And I'm sure he must have kept it very simple. So it was from there development began, evolution, foundation, they began to build on it, other forms of C advancing here and there, but it was basically the foundation. In fact, the foundation of low assembly language. And it's from there they built upon it and continue to build, founded low-level languages, and from there founded high-level languages. So C originally is one of the very first step away from machine language. And it's a big success because even today, we still go back and learn C, even though we don't learn it in the form of assembly as it was then. We learn it as high-level languages now, yes. But it's important to mention this history that C originally started as an assembly language, and it was the birthplace of assemblies, assemblers, and all. Yes, running C of today will require an environment. As you can see this image here, the Turbo C++, yes, it's just the name, Turbo C++. So that's compiler environment is compatible with C programming, C++, C#, whatever C versions you can find, although some of them have restrictions. But it's a good platform to have on your PC. Even the mobile version of it is available. Just have it downloaded, installed, and you're ready to have some lines of code execute, and you see them perform. So here, Turbo C++, a couple of things we'll be enjoying in this course is to create and write source codes, understand control structures, understand functions, pointers and arrays, and all of those. So creating the source code in C, of course, it starts with having the environment installed. Open the C compiler. It looks something like that, yes. And then you click on the file menu just as much as we are conversant with loading a file, the documents, whatever desktop, Windows application. You go to the file menu, click open, search for the file, and then double click on it or single click and click on open. And then it opens the file, and then we see all the codes. And if it is a new file where we have to start writing codes, yes, it opens a new file. You see the introductory line, those very basic lines that are very, very important, and you cannot do anything without those lines. They are just there as basic. Then the lines for you to start to impute your own codes, they will show up in there. And it becomes something you can just begin to work with. Okay, so here we see this name C/tcwin45/bin/noname00.cpp C++. So this is a file in C++ waiting to be loaded, and this is just the compiler environment of Turbo C++. So this is about locating the file, and all of these pictures just tell us how to navigate through. So the best bet with this is to download this app on your PCs, or there's a mobile version to it. I have one on this device I'll be sharing with you in the course of this course. We'll be using it also to have some programs executed. So let's look at elements of a C program, a C set of instructions, just a problem for which we have provided a solution to. So the solution in codes in C language. Let's look at what it entails, the elements. The first line there says the elements of a C are like the main parts of a C code, and they're divided into three parts. The A there says program comments. The B talks about the include statements, and C, the main function. And there is a deep fourth part of it now, identifiers and keywords. So let's take note of those four. We'll be dealing with each of those, and they will open us up into a lot of other things. As a matter of fact, the entirety of C language is covered by this material. Everything we need to discuss about this language according to this material, the scope that this material covers, they are all grouped into those four. So by the end of the fourth part of the elements, identifiers and keywords, okay, just a couple of other things, then we will be done with this course. But we will be dealing extensively, like we said, this is the first programming language and the foundation of which we need to build very, very formidable, just so we can be able to build upon it. Yes, program comments. What are program comments? In simple English, those are those lines of codes that explain the purpose, the motive, the whole idea. Part-time, yes. Okay, so a couple of codes are being written. They are all machine-compatible codes. Sometimes you as a human being will be wondering, what is this? What are those? What is it supposed to mean? So there is a line that will explain to you what is happening in the next line. And there's a kind of code that makes that line readable and understandable, that this is an enlightener, something to enlighten you now. Say, okay, I wrote the codes and I'm sending off to you. You didn't write the codes, but you have the codes to go through. Something along in the line of codes must tell you, this is what I'm trying to achieve with this set of codes that I follow. Okay, I want to add this and that. And then you see the lines of code that actually does the addition. But without you reading that comments, you may not understand what goes on in the next 3-4 lines. So the program comments is that line of instruction that explains to you what's going on maybe in the next 2-3-4 lines. And after that next 2-3-4 lines, maybe another line comment to tell you what goes on again the next 4-5 lines. So part-time, where there are explanations to be done to anybody who will be called that code, comments can be introduced. Brief comments to just tell you, this is the point where we do this. Okay, so when the person reads that line, he now goes through the next 3, 4, 5, 6, 7 lines and says, okay, I see, this is what they're trying to do based on what has been written in that comment line. So program comment there are those line of comments that explain the action that is to be performed by the next few lines of codes, or basically the action that is to be performed by the whole lines of codes. In case the code is just a short code, maybe 10 lines maximum. So 1 or 2 lines of code will explain everything that the whole code is meant to achieve. Now, once you just read through that code, that line of comments, you know what the code is meant to achieve. So I read the note under this program comments. Program comments are explanatory statements that you can include in C code that you write to give an overview of what the program is about. All programming languages allow for some form of comment, yeah? C compilers evaluate these lines of comments not as an executable codes. Of course, they are not instructions for the computer to execute. They are just like recessive, dormant, not dominant, not active. They are passive. They are just there. And they have some kind of a encoding that comes with it that lets the computer know that this line is not executable. But we'll see how it applies as we go on. C compilers evaluate these lines of code not as executable codes. As a result, when we run our executable file, these lines of codes are effectively ignored. It could be in this form. Now look at this. Look at this. So there goes the program comments line there, written in that format as we see highlighted. The / asterisk, then the comments. This program displays hello in quotes, exclamation mark, and then it's ended with an asterisk and a /. Now, please take notes of the opening and the closing tag on this line, the / asterisk, and then the closing asterisk and the / in that order. And so this works for one line at a time. Open tags, the comments, whatever quotes and everything, then the close tag. Another format to this is what we see on this other line here. And this is about using the double /. This only works with an opening tag. And it allows, in some programming languages, it allows for multiple line commenting. Multiple lines. So when you write the first line, you have a long comment that will take more than one line. With multiple tags or double tags, you comment on multiple lines until you have a space, an escape sequence of space before that double forward tags ceases to work. So you just have to study each programming language to see what works. But in this case, we'll understand that double / works for at least a line at a time. When we get into the programming sequence proper, we will see how many lines it works for and what obtains with C and the likes of it. So that's about it for the comments in C language. Next off is the include statements. The include statements. Now the include statements, like the name implies, include, which suggests something that would not have ordinarily been part of the bigger picture, but is now allowed to be, possibly because it has a bigger advantage to play to the bigger picture. Otherwise, there will be no need for it. Or we could make do without it. So let's put an analogy to this. Include statements. Say, for instance, an English teacher has a class to deliver to some primary students, and the topic happens to be vocabulary. So the English teacher does not need too much of words, but can just introduce the topic, the words and their meanings, and there is a repository where you can find words and their meanings, the parts of speech and everything. And so the teacher introduces the topic and begins to teach, and then one or two words and their meanings and so on. And when other words are needed, he refers to the dictionary and tells the students, open your dictionary, find me this word. It even teaches them how to access the dictionary. So that's what include statement does in C language. It gives us access to a repository of pre-programmed operations that becomes useful in our code. Take, for instance, we are having a mathematical coding. We are trying to solve a mathematical problem, and we need to access pre-programmed operations like sine, cos, tan. We do not have to start writing the codes for all that all over again. In C language, they have been pre-programmed and stored in the C compiler in a file, in a folder. So we only need to have the access to that folder and then call the names of those files such that they will come and run. They give us their outputs and go back, and we will continue with our own solution in our own code. So that's the whole idea of include statements. The very, very basic one we must have in every C program is the stdio.h. That's a file, stdio.h. And I'll show you very briefly how it is written, the include statement, and then you mention the name of the file you're trying to access. So the stdio.h is such that it allows the input-output operations to become functional. Say like in C language, we use printf to output, to print out anything on the screen, to display something on the screen. Like you see in the comment above, this program displays hello. So when we finish writing the program in question here, hello, it will display hello on the screen. You will see us use the printf somewhere in between to definitely put out the hello. And also to receive values, to receive inputs from the user, like a prompt, we use the word scanf. So the output is the printf, the input is the scanf. But for those two pre-programmed functions to become functional in our codes, we must have mentioned the stdio.h in our include statement. Otherwise, they will not work. So let's read this note and we have a little better understanding. Include statements. This is one of the most important line of code in C program. There you see that #include space angle bracket open stdio.h angle bracket close. I'll make that easy for us to recall. Studio.h stdio, we call it studio.h. It stands for standard input output dot header. Now I read on. These are also known as header files. They are found in a special directory that is established when you install your computer, with each one providing the program we write with a different piece of functionality that otherwise we would have to write ourselves. So they've been pre-programmed. We just call them and make use of them and we move on. As to the particulars of studio.h, the letters IO in studio.h refers to input-outputs, which is a computer term that describes how data is input into our programs and how we get information out of them. If we fail to include the studio.h file in our program, we wouldn't be able to display the words hello. So we can see that these are a repository of pre-programmed operations that when we have access to them, then the files inside those folders become functional in our own codes. And we can get a lot of things done by just having access to them. Right. Item C, the main function. Main function. I'd like you to understand that C language is such that every line of code belongs to a function. It's so structured that every chunk of code, every line, every 10, every 15, every number of, in fact, the entirety of codes in C language belongs to a function. And how do you know a function? I'll quickly take you to this line. You'll see a data type declaration and then the name of the function. The data type here is the int, referring to integer. And then the name of the function itself, main. And then you see the open and close parenthesis, the complete parenthesis, very close to the name of the function. And then it goes on to have the open brace and the close brace. The open brace and the close brace. Now, within the open brace and the close brace will be everything that belongs to that function, every line of code. We will talk more about functions when we get further down, but what are we talking about here? The main function. Everything belongs to a function. And so every sub-function, every smaller function, all belongs to a bigger function. A mother function over their children. An umbrella function. The entirety of all the codes, no matter how big, how voluminous, 10,000 lines of codes, they all belong to one function. That is the main function. It is the very first function we have in any C program code. In fact, even if it is just one line of code, it must belong to a main function. And if I have 1 million lines of code, it must start with a main function. And then every other thing comes in one other function or the other within the main function. So let's just understand the main function is like the mother function. Let's read this note here. The main function. The main function is a section of code where the major instructions of a C program are placed. It contains the data that are declared as variables or constants, the objects created from classes, namespace declaration, data type declaration, and others. These are other functions that can be created in the C program, but the main function must be created first. Without it, there is no existence of the code. So it's the mother of them all. If you start a C program without, even if you want to say, okay, my own function has a name, I'm running a program to solve calculus or whatever, you just must start with the main function. You must include that word, int main. And then you begin to put whatever it is solution you're trying to code out. The above int main, I read on now, shows that the return value of the main function will be an integer value. This unit can be read simply as a text. However, it is intended to be interactive. That is, you should be compiling, modifying, and using the programs that are presented herein. So the main function there, whether it is declared integer, data, whatever, is just a basic line. And it guarantees you compatibility, whatever it is you want to put. It keeps you away from error. But if you try to change anything about the main function, that name, that data type, then you could start experiencing errors. So leave it as it is. Whatever things you have business is with within the main function, within the braces now. Look at this line here. Look at that include statement. # include, angle bracket, studio.h close. Then the int main with this parenthesis, and then the open braces. Print F, welcome to my world, close brackets and semicolon, and then return 0. Now this is a complete C program. As simple, as small as is a complete C program. You see the main function there, open braces, and everything that has to do with what we are trying to do comes between the braces. And then the use of print F there has made sure that there is a studio.h. Otherwise, that printf will not work. Mind you, because of my experience with programming, the capital P of that printf will generate an error. Printf is actually small letters all through, lower cases. When we get into the program environment proper, we will intentionally make this mistake and see how it goes. But I'm telling you, that P will generate an error there. And then the return 0. That return 0 is just a way to ensure that you're closing out. You're successfully closing out the main function. Every main function must have the last line as return 0 with the semicolon and then the closing brace. Mind you, every line within any function must end with the semicolon. Those little things can generate errors that can go on for days, weeks, if not noticed. Now let's read this last line here. Note, all lines of code in C statements must end with a semicolon. Else, the line of code will not be executed by the compiler. In order to output text to the monitor, it is put within the function parentheses and bounded by question marks. The end result is that whatever is included between the quotation marks will be displayed on the monitor when the program is run. C uses a semicolon as a statement terminator, so the semicolon is required as a signal to the compiler that the line is complete. I'm sure that makes complete sense. Now, on the last item here, item D, identifiers and keywords. Very interesting here. Now, so far we have heard of some words that have predefined meanings in C language. Words like main, it's the name of the main function. Printf for outputting. Scanf for inputting. We have seen return is the last line of every main function. So identifiers and keywords suggest a group of words that have been removed from the English language vocabulary and given predefined meanings in C language such that a user has restrictions in the use of those words. And there are two categories of those. There's the identifiers and there are the keywords. Let me pick on the keywords first. The keywords are system-defined reserved words. System-defined. C compiler has a meaning for them. You cannot gamble with it. You cannot, if you must use those words, it has to be the meaning that C compilers has for it. For example, sine, cosine, printf, main, all those words that they just have their meanings as predefined by the compiler, C compiler environment. So you want to use that word, it means you want to do what C defines it to be. Otherwise, nothing. So those are keywords, system-defined reserved words. Now the identifiers, on the other hand, are user-defined reserved words. User-defined there could mean you as a user pick on those words and give them your own meaning. You give them a predefined meaning, maybe in the beginning of the program, the beginning of, just as you resume the main function, you now pick out some words. Some, no, some is actually reserved. Okay, no, some is not. You can just pick up anything. Name could mean the name of the person. Age could mean this. Just give the predefined meaning, some words that are available. They are not reserved by the C compiler already. They are available for your own use, but you now define them to mean some particular things, such that anybody, any other user who encounters your program and has to use your program cannot use any of those words besides the meaning you have predefined them for. Those are identifiers. They are user-defined reserved words or user-defined keywords. But let's separate them. Keywords are system-defined reserved words, while identifiers are user-defined reserved words. So when we understand those, and then there is a naming convention, how you go about naming. As for the keywords, system-defined, you don't name anything. They have just been taken as they are, just use them as they are. But for the identifiers, the user-defined reserved words, there are conventions you must follow to get the naming right. Some characters are not allowed, like space. Some characters are compulsory that they must be the first. Some characters, they must contain numbers and letters, and all those naming conventions also apply. So let's read through these notes. I'm sure it will explain a couple of things that apply with identifiers and keywords. I read, identifiers are names that are given to various program elements such as variables, functions, and arrays. Now, these are things you name yourself. Variables, functions, and arrays. Now, it's not the same as the main function. The main function is just there. You can't name that one. But you can decide to have a sub-function in the main function. And you could give it your own name. So, it suggests the things you can name: variables, functions, and arrays. Identifiers consist of letters and digits in any order except that the first character must be a letter. Now, that's part of the naming convention. Both upper and lower case letters are permitted, though common usage favors the use of lower cases for most types of identifiers. Because C programming basically allows small letters the most. Most of their keywords are in small letters. So it becomes a practice for a user, a programmer, to stick with that. Stick with the small letters. Just know how to differentiate your keywords from the identifiers. But there are some other languages that are case sensitive. Case sensitive. In such a language, it is advised for the programmer to now stick to being case sensitive. But here, just stick to the fact that only lowercase letters are mostly in use. And it goes for a good programming practice on the part of the programmer. So upper and lowercase letters are interchangeable, yes. That is, uppercase letters is not. Now look at this. Upper and lowercase letters are not interchangeable. Pardon me for that. They are not interchangeable. That is, an uppercase letter is not equivalent to its corresponding lowercase. The underscore character and that can also be included and is considered to be a letter. Okay, so you can have a naming convention. Name boy, name underscore boy. That is the name of a boy. Then another variable, name underscore girl, the name of a girl. So when you now say, enter the name of a boy, you on the back end, you have created a variable, name underscore boy. It is supposed to accept the name of a boy. And then when you now prompt, enter the name of a girl, you pass it into the variable, name underscore girl. So that naming convention, name underscore is allowed. Okay. Now I read on from here. There are certain reserved words called keywords that have standard predefined meanings in C. Talking about system predefined now. These keywords can be used only for their intended purpose. They cannot be used as programmer-defined identifiers. Can you see that? Cannot be used as a programmer purpose, reason, definition. They have their standard definition. The standard keywords are auto, extend, size of, break, float, static, case, for, struct, and so on. In this category, we'll see printf, scanf, where we get to control structures, while, do while, for, switch, and so on in C language. All those words are keywords, system-defined reserved words. All right, so having dealt with these 4 main parts, we're beginning to go into the rudiments, talking about data types and declaration, data variables and constants, control structures, arrays, and the likes of them. But if it is not properly handled, these things could become more confusing than we could understand them. So at this point, we will take a quick break and go into a compiler environment. Let's begin to familiarize ourselves with what we have discussed so far. We'll be back in time to discuss from this point 3.2, data and variable constants. Data, variables, and constants, okay? So come with me. Let's go do some program execution. Let's go and create some intentional errors. Let's go and see what else will present itself for us to talk about, which we will still encounter later. I particularly use this platform, CXX Android. But of course, the Turbo C++ is also a good one. I'm sure that's what most I recommended to use. But of course, if you become an adept programmer at some point, you would want to look for something much more than just the generic platform. So I use this one, CXX Droid. From the name, it's quite compatible with an Android phone. So sometimes I just do some things on a mobile and save them here and there and have access to them across board. So here's my CXX Droid. You can find it on Play Store, download and install. And then you can play around with it. Has some file menus for you to open, new, search. Okay, this here, new, open, save as, and all those other menus that you're quite conversant with. And so here, this right here on my page is the basic page for a C program, the main function. It doesn't have any include statement yet, just the main. As you can see, it's under the name new. I click on this one, new. This one, new. So every new on this CXX Android comes with this. It comes with this. Don't forget, this platform also allows for C++ and other variants of C language, but we'll start off with C. And so I have here an already coded solution. This is entitled SimpCalc. SimpCalc, simple calculator. SimpCalc, simple calculator, as the name implies. What this is meant to do is to run a calculation operation, simple calculations, addition, subtraction, multiplication, and division. So let's just see what this will help us to achieve with those 4 operations. First off, let's go through the lines of code so I can explain through a couple of things and refer to the things we discussed and a couple of things we would also meet ahead. It's not very long. Most 48 lines of code as we see here. And then we would also do the execution and we would move on from there. So first line here includes statements, #include, angle bracket, studio.h. That makes sure that our input outputs operations are accessible within this line of code. Then we have the int main, the main function. You see there the parentheses and the open brace. The open brace. We could decide to bring this one down here. It's just about you, the programmer, whatever is convenient by you. Open brace there. And then so within this main, we begin to declare variables. Variables could be anything. Don't forget they are identifiers, the things that you use to identify whatever values or data that you want to use within your program. So there's a data type declaration here, char, character, and then the op is the variable name, character op. That op stands for operator, just the short form for operator. So I'm asking that create for me a variable op of the data type character, suggesting just a single character, not a value, not a number, not an integer, not a floating point, not a double, a character, special character. Don't forget, it's supposed to capture things like plus, minus, times, divide, and only one character at a time. So that data type character is allowing space for a special character, and I'm giving it to the name op. That op is like the identifier on the memory space. On the memory, it's supposed to have a placeholder and then the contents. The placeholder is the name op, and then the contents of the placeholder is now what will be brought in. Either it is addition, plus, or subtraction, minus, whatever will be brought in to represent the operator at that time. So variables are like placeholders and then contents. The variable name themselves are the placeholders, and then the contents is what they carry, which is already declared in the data type character here. Now, the next line, character name, and then the square bracket 10. This is an array declaration. Character, yes. Name is the name of the placeholder there. Name, sorry about that. And then I create an array of 10 spaces, because what I want to enter in the variable name is not just a single character. Yes, it's a character, but it will take about a number of characters. So I'm creating 10. Mind you, it's a name. So anybody can enter the name, and then at least 10 spaces should just accommodate whoever. I'm just asking for the first name, that's all. And then the next line, double. Double there is a data type that allows for long values. Long values that you can hold up to in millions, billions. High precision values. And I have two of them, first and second. So I'm using this data type declaration double for two variables, first and second. See how I end each line with a semicolon. Each line ends with a semicolon and is all still within the main brace, the main function open brace. Then now the printf. The printf, that is my output statement. Do not mind the /n and the t. Those are just escape sequences. We will see that as we go on. The /n suggests a new line. So whatever I'm printing in that printf will drop to a new line. And then the /t is for tab, indentation. So I've gone back and forth within my output space. I see I want my output to be well indented and well spaced out. So I had to put in those escape sequences. The more you engage in these, the more you see how this works for you. So now, hello there, my name's Simple Calc. That is going to be outputted. It's in the quotes. And then it asks, what's yours? New line tab, what's yours? So all these are going to be output. Everything in the parenthesis of the printf will be put on the screen, an output statement. Then the scanf has a %s and then name. %s and name. The %s is a kind of a format for inputs. % is asking, the prompt, and then s there is the string character type. Asking that whatever is coming in with this scanf command must be a string value, and it will be stored in the variable name. Don't forget I already declared name earlier as a character with 10 spaces. So get me a string of characters. Character is just a one letter, one symbol. But now S there suggests a string of characters. So 3, 4, 5 letters put together make a string, all inputted into the placeholder name. Not more than 10, of course, as declared earlier. Then the printf there, how nice to meet you. All these are just sequence of input and output. As you can see, how nice to meet you. And then it outputs the name that was imputed earlier. Then I ask again, printf, Kindly make a choice of operation, the plus, minus, times, divide, and enter plus for addition, and enter minus for subtraction, enter asterisk for multiplication, enter the slash, backslash for division. So all of those, you will see them properly arranged when the execution is done. And then there's a prompt there asking for the operator. You can see that now. The percent sign is the prompt asking me for a string, and then an operator variable is waiting to receive the value that will be entered, whether it is the plus, minus, times, divide. The operator is waiting to receive. And then going forward, now look at this comment line. Enter the first number. That line with the / asterisk is not executable, like we said earlier, but it only explains to whoever is running this program now what is about to go on in the next few lines. So enter the name, first operand. Okay, enter the first number, and then printf, first operand. The scanf statement is the prompt for the first number. And then another print statement, enter the second operand. And then the scanf again is the prompt for the second one. And then the calculation goes on here. Take note how we do the comments in this line, the double / and only for that line, the double /. Then the switch operation, it's a control structure. Switch is also a keyword, system-defined reserved word, switch. It's a control structure. It seeks to give control and pass an operation here and there. When we get to control structure, we'll explain better, but this is just the use of a switch function. You can see its own parenthesis there, having the OP as its own input. The switch function, open bracket, OP, the operator which we imputed earlier, is now its own input, close bracket, and then you see the open braces. So the switch is like a smaller function within the main function. And so switch case plus, then printf, 2 decimal places, you can see the percent sign .2, 2 decimal places plus another prompt for 2 decimal places, and then the answer is given in 1 decimal place. And the first thing in 2 decimal places is this first here. The first prompt here, this first prompt in 2 decimal places refers to this first value. And then this second one here in 2 decimal places refers to this second value. And then this one equal to prompt in 1 decimal place refers to first plus second on the case that a plus is entered. In the case of a plus, the first plus second is added. And then there's a break. Break means you break out from that condition. Having satisfied that this is a plus, now we have done the operation for plus, first plus second, you break out completely. But in the case of a minus, let's assume a minus was entered, it will skip the plus, go straight to look for what the operator carries. The operator carries a minus, it will go to the case of a minus. And then 2 decimal places, which refers to the first value that was entered, minus 2 decimal places here for the second value, and then the answer is in 1 decimal place for first minus second, and then it breaks out. And then if in case the operator is a multiplication sign, it skips the plus, it keeps the minus, it comes straight to this place and does the same thing, 2 decimal place here times 2 decimal place here, and for answer 1 decimal place, referring to the first, second, and then first times second. And for the last, in the case of a division, does the same thing, 2 decimal places for the first value divided by 2 decimal places of the second value, and gives your answer in 1 decimal place for first divided by second. Now, this is whether you impute 10 decimal places. Even if you input values more than 2, 3, 4 decimal places, it will break them, approximate, estimate, whatever it needs to do. It will put them in the specified number of decimal places, and then it breaks out. And then you can see here, this line here, we see how the / here allows for multiple line comments. Although, because the screen of my device here is small, it looks like it's multiple line. It's actually still on the single line. So the operator does not match any case, then we have a default part of that switch case. The default part. In case the operator is not a plus, or a minus, or a times, or a divide. If anything else was entered besides those four, it now prints this error message. Operator is not correct. So it's just like a default, a last resort in case there is anything beyond what is supposed to be. And then after that, this now is the end of the switch, the closing brace for the switch statements. As you can see here, I put my cursor here, and then this place is highlighted. So the opening brace of the switch here, and then its corresponding closing brace here. So now we go back to the main program, and there's an output statement that says, thanks for stopping by. And it calls again the name of the person who was running the program, having provided his name from the beginning. So, and then there's our last line, return 0 from the main program, and then the last closing brace. So this is just one complete C language trying to do some simple addition. We will go ahead now and execute this and see how well it runs, whatever errors. I will see the flow of the whole program and we'll learn from it. So follow me as I go. Okay, we have some errors here. Okay, let's look into it. I'm sure it's just something simple because last time I worked on this, there were no errors. Okay. Scan F. Line 21, character 25. Okay. This undeclared identifier 1. There's something that my hand must have entered here, which was not supposed to be part of this. 43, 4. Let's go to line 43. Okay, look at this. Line 43. This thing was probably when I was trying to show the braces. So this part of it, this last character after the brace is not supposed to be part, and that just brought up an error. So we'll have to remove that. Yes. And then rerun this program. And voila, it's executing. So I'll just go back again and save me what I just did to be sure that I'm not making any alterations again, unwanted modifications. So save this as simple calc. Take notes, I'll show you something very quickly. The name simple calc here, this name that's been highlighted, does not carry any asterisk. But if I do this, I just put an enter. I just try to do something modification here. And then it carries an asterisk, simplecalc.c asterisk. That shows that a modification has been made and has not been saved yet. Has not been saved. So anytime you see that asterisk, it shows that you have done some modifications, but you have not saved. So I will go ahead and remove all these things I just put. And then by the time I now go to save, that asterisk disappears. It has disappeared now. Good. So we can go ahead and execute. And there it is. Hello there. My name's Simple Calc. What's yours? Now you can see how the output is being dropped to a new line. What's yours? That's the work of the /n. And then it's indented. Otherwise, this hello would have started from the very beginning. Let me quickly remove one of the tabs, and you see how this would have been. Oh, pardon me for this. Okay, so I'm back to the code segment, and I want to deal with this line that says, hello there, my name's John. So I'm going to remove the tab, the /t. I'll save that. Just so you see what the tab is doing. The /t. So you can see the hello had to begin from the very first indent of the page. But because I see that place is so close to the corner, it may not be clear enough. I had to use my indentation to bring it out. So I go back to my program. Oh, pardon me for this. I go back and I include here /t. And I go ahead and save this. And then we run this. And there we are. So, hello there. My name's Simple Calc. What's yours? And so let's just say I put my name is Joe. And then I have to click and enter. Every time I put in an input, I have to click enter before it goes to the next one. How nice to meet you, Joe. Kindly make a choice of operation. Plus, times, minus, divide. Enter this for addition, enter that for. And so I now say, okay, I want to just carry out a simple addition. I've entered my plus there, and I hit enter. And it says enter the first operand. So let's say 1, 2, 3, 4 dots, dot, 4 decimal places there. And then I hit enter. It says enter the second operand. And I go by this, dots, dot. Okay. All right. So I have both numbers in 4 decimal places. And then I hit my enter again. And see, it takes my first number 2345.57, having approximated it from the 2345.5678, approximated it to 2 decimal places .57, then plus the second number 5678.7890 approximately to 79, approximated the decimal to 79, 2 decimal places, and then my answer comes out in 1 decimal place, 8024.4, as was stated in the program, as was put in the program, as I just made sure I did those definitions. I don't want my answers to be too much of a decimal, and I can as well allow for 3, 4 decimal places, but this is just what I specified, and that's what is coming out. And then the last line there, thanks for stopping by, Joe. So this is just a simple form. It could as well be built up to ask if that is the last thing you want to do, if you want to carry out any other addition, or if you want to carry out any other operation. It could be modified and built to become bigger and robust. But this is just a simple form for us to at least have a good view of the C programming language environments. So we go back here, and let's just say we want to pick on another operation. We rerun this. Okay. Put in again. My name's Kel this time around. How nice to meet you, Kel. Pick up a simple operation. I go by, okay, I want to do multiplication this time. And I hit my enter. The first operand, this, that. And then the second operand, this, that. Doesn't matter. And then it takes my number, approximate it to this decimal place, multiply by that, approximated to 2 decimal place, and my answer is in 1 decimal place. And thanks for stopping by, Kel. So you can see this is just a back and forth, a simple form of this. Now let's say we decide to give ourselves some error scenarios. Let's start with the P I talked about earlier. Which one? Okay, let's do the very first one here. The print statements. Hello there, my name's. So we're going to remove this P and put a capital P there. And let's just go ahead and, okay, we don't save this. And then execute this. And then it goes with an error. It goes with an error. And the error is just pointing somewhere here. You may not be able to see it. Somewhere here it says printf. 1, 2, 3, the 4th line after this first warning. The next line after it, capital print that is invalid in C99 and all of that. It only says that the capital P is not recognized. So let's go back to show that this is where the error actually is. And go and correct that capital P to a small letter P. And go ahead and save that. And then rerun this. And then it's gone. So that capital P was just the error there. What other type of error do we want to give ourselves here now? Let's say we want to pick an operation that is beyond the 4 specified. So let's go ahead and run as is. And then I put my name as day. And then I pick for my operations, plus, minus, times, divide. Let's just say I pick up something that is not in the list. Ampersand. And it says, okay, enter the first operand. Yes. It still goes on to run as is. But when it comes to the point of trying to check the operator to perform the calculation, that's where it picks out in your error. So I forget to enter my number. Oh, enter the second operand, and then error, operator is not correct, thanks for stopping by. So you already flagged that error, you cannot continue. So all these things can be modernized, modified to be able to perform better. But this is at least an introduction to the C environment. And it's been an awesome experience coming in here, just so that many of the things that we have been talking about become more familiar, and many of the things that we will talk about will refer back. We'll refer back to this place and say, yes, you saw that the other time, you saw that the other time. So at this point, let's just take a break and we get back to our text. Right. So now going into some rudimentary elements of C programming language, we'll be kicking off with data. And data here, we'll be discussing on kinds of data. Kinds of data. Of course, data is that thing which is supposed to be manipulated in the course of a program. It could be text, variable, whatever. Something imputed or something already existing in the course of the program. But whatever it is that is being manipulated is data. So there are two kinds of data, the variables and the constants. The variables and the constants. A variable, as the name suggests, is anything that the value changes in the course of the program. In the course of the execution, the value can change. It may be initially stated, it may be initialized. Now don't forget we mentioned variables as placeholders and contents. Placeholders and contents. So a placeholder is the variable name, and the value that the variable carries is the content. So now what we say can change is the content, not the variable name, not the placeholder. The content can change in the course of execution. It may be initialized from the beginning. Okay, this variable name is set to this. But in the course of the program, calculations, manipulations, things happen to that variable name and changes the content. And so why it's called a variable is because the value is not static, it's not fixed. It's allowed to be changed. Whereas on the other hand, constants are such identifiers whose values are fixed from the beginning throughout the course of execution. They are fixed, they do not change. They just remain as they are, and they are used as such. Whether manipulations occur, whether anything that happens, it does not change the value of constants. So reading through this material, you can see a couple of different types of constants there. There's the integer constants. One of such integer constants is the pi. Pi, you know pi in mathematics, 3.14159 is approximated to 3.142. So if you're doing any sort of calculations and you have to bring in the value of pi, pi just has a value that does not change. You can set it as 3.142 and that becomes an integer constant. So every time pi is utilized in the course of your program, the value 3.142 just goes into the program and executes, and then we move on. The next time pi is called, the same value goes in. No matter what happens to pi addition, pi remains pi, integer constant. Okay, permit me there. 3.142 there falls in the category of floating point constant because of the decimal, floating point. But integer constants are more of integer values. Integer values, 1, 5, no decimals, no floating points. Integer constants, integer valued numbers. Whereas the floating point constants have the decimal values, the floating points attached to it. You can see some examples there for the floating point constants. Yeah? Okay. And then we also have character constants. Character constants, X, A, Z. All these are values that are attached to a placeholder that do not change. There's also the string constant. The string happens to be a combination of characters, whether letters, numbers, symbols, whatever. It's a combination of characters put together, mix up a string. Now, one thing about constants is that they are declared in quotes. They are assigned through quotes. Say, for instance, you have a name, an identifier. and you're supposed to initialize it with a value. What makes a constant different from a variable? If the value assigned to that variable name is put in a single quote or a double quote, that makes it a constant. It means that chunk of data in the quote, single or double, is assigned to that name and nothing changes it. It's just a constant. But in the case of a variable, we do not use quotes. We just go ahead and assign the value to the variable name. You see that in the next segment here where we go into variables. Please take time to go through the notes on constants. It's self-explanatory. It doesn't need any much of explanations. And so variables here now. Variables, we see these identifiers that are used to represent some specified type of information within a designated portion of the program. Yeah? Specified type of information. They could be values declared in a particular data type, but usually they are values that may change in the course of the program. They may change. And so they are declared from the beginning. The variable names themselves, which are the placeholders, are given a particular value. And then they are told to keep that value. In the course of the program, anything changes, the value themselves may change. The contents may change. And so the placeholder will now have to carry new contents as we go on. And as we see some form of declaration in this box here, int ABC, int there suggesting integer, the data type. We'll be going into that right after this. Integer, then the variable names A, B, and C. All of them declared as integer. Int ABC. So those are three variables declared as integer. You saw that in the course of the program sample we went to view a few minutes ago, where you saw double first and second. First and second were two variable names declared with the data type double. So here int ABC, and then the second line here, character D. D is a variable name declared in the character data type. And so we now see at this point where A equals to 3, B equals to 5, C equals A plus B. A equals to 3 there is assigning the value 3 to the variable A. We call that line initialization. Initializing the variable A as a placeholder to carry the value B, value 3 as its contents. And so A becomes a variable in that it has a value. Take note that there are no quotes, single or double. There are no quotes. The variable B, being the placeholder, is carrying the content 5 as its value. And then C is carrying the addition of A and B. And then D now is assigned A in quotes. D is assigned A in quotes. That A in quotes is more like a constant. Everything about D is the value of A. And don't forget, A is not fixed. A can change at any time. Although in this program, A remains 3. But in the course of bigger programs, something can happen to A, and then a new value is saved for A. But in the course of this program, A is fixed to 3. It's a variable. And then D carries the value of A at any time. And then again, the next line says A equals to 4. So the value of A just changed now. From 3 becomes 4. B changes to 2. And then C again is A minus B. And D again is W. Look at D being W. W doesn't stand for anything at all. So that D there suggests a constant declaration, while A, B, and C are variable declarations. The first two lines are type declaration. The first two lines, int A and B and C, which states that A, B, and C are integers. I'm reading through the notes in that line now. Okay. And that D is a character type variable. All right. They are all variables. And then, thus, A, B, and C will each represent an integer valued quantity, and D will represent a single character. They are all variables. D will represent a single character. Now, we go into data types. Data types. Now, these data types talk about the type of data We have talked about constants and variables. The type of data. This is where we begin to talk character, string, floating points, integer. What type of data is expected, whether it is variable or constant? What type of data? Don't forget we mentioned pi earlier, 3.142. That is floating points. Floating points type of data. And so go to the table. There you see int, integer quantity with 2 bytes or 1 word. That is just the memory allocation, 2 bytes or 1 word. Then we see the character, char, single name, single character, spaced as 1 byte on the memory. Then we see the floating point numbers, that is numbers containing the decimal point or an exponential. We have 1 word space for it, that is 4 bytes. And then double precision floating point numbers, that's more significant numbers. The more significant numbers suggest like 8, 10 digits. More significant numbers, high profile numbers in millions, in billions, which may be in larger magnitude. They all have the space, 2 words, 8 bytes on the memory allocation. So all these are just data types that we could manipulate in the course of the C program. And then now we go into the operators on data. The operators, we saw a couple of that in the sample program we went to earlier. Operators could be arithmetic or logical. Arithmetic are just the simple mathematical calculations. And then the logical could be comparison. Let's see below here, 3.4.1, we see the arithmetic operators in C are addition, subtraction, multiplication, division. And then we see the logical here. Logical operators, there are 4 logical operators. They are the greater than or equal to, less than or equal to, then strictly equal to, not equal to, the and or the or. Those are all logical, relational, just comparison kind of operator. So you can be running any kind of operation that you have to do some comparison. Logical operators are introduced. Okay, and so looking at this point, we have some exercises here. I'd like us to go into those exercises. It's very important that we have a sneak peek and have an understanding of what these are talking about. Our first exercise, reading from here now, our first exercise, class exercise on how to work with the C program. Write a program to print numbers using your own identifier. We've been told what identifiers are, just placeholders. To print numbers using your own identifier, write a program to display your name on the monitor. Modify the program to display your address and phone number on separate lines with 2 additional printf statements. So, to write your name on the monitor and display the address and phone number on separate lines, adding 2 additional printf statements. That follows a program to print numbers in your own identifier. Okay, so I actually have something targeted at this, but before we go into that, there's a sample response to that question. I think the question 1 here, question 1 that says, write a program to print numbers using your own identifier. Yes, here you see the sample in the main function, then the open brace, index, integer declaration there for the variable name index, and then index equals 13. Now printf, the value of index is %, double declaration, new line, then the variable index. And then again, a new value is added to index. A new value is declared, initialized for index 27 and printed out. The value of index is now, the new value of index will be printed on this second line. Then the third line, a new value of index 10 is assigned. And then when it encounters this next line here, what was that? Okay, when it encounters this line now, the value of index at this line now will now be the most recent value, which is 10. So this construct here assigns 3 different values to index at 3 different times, and at each time prints the value, the present value of the variable index. So at one time, it will print the value of index is 13. On the second line, it will print the value of index is 27. And on the third line, it will print the value of index is 10. Take note, it uses a new line escape sequence at each of the print statements. So it's going to be dropping each print on a new line, And so that answers question 1. Write a program to print numbers using your own identifiers. I have some program construct that put together question 2 and 3. Question 2 and 3. Write a program to display your name on the monitor and then modify to show the address and phone number on the separate lines, adding 2 additional printf. All right, so we'll be going into that shortly. Yeah, when we get back, we'll be discussing control structures. So very quickly, let's go see what we have for the name and address, phone number sample program, just so we can see. And of course, I'll always have one thing added to my own sample codes, just to make them a little more beyond expectation. But if you can study through, you'll always will make better value of what I'm offering you here. Okay, so I think I have it here. Name, address, display, okay. So I've named it name, address, display. I made it a little interactive, just beyond printing out name and address and phone number. I made it interactive such that, okay, someone's speaking, somebody's responding, and then kind of a conversation. So the important thing is to study how the use of the print statement goes and how it outputs per time, and how the scanf statements also prompts for inputs. Study it so you can make any form of modifications into it. Look at my, put some interactive program comments here to explain what the program is doing. Online sync compiler run a C program. I have my include statements there, the studio.h and the standard library.h. And the int main. And I see a comment here, write C code here, okay. Integer declaration of I to be initialized as 0. The character name declaration of an array, 6 spaces. Character address array in 10 spaces. Character integer age array, 3 spaces. Then character language array in 2 spaces there. And so my printf statements outputs that, hello there, my name is main. And on a new line tab, what's yours? And it prompts for a name to be entered into the variable name. And you just study through this program, see how it, in the place of the address, I didn't put a particular address, so to speak. As you can see, the name I put for the program is the word main. So it's like you're interacting with a computer, a machine. So, hello there, my name is main. What's yours? So you could just, okay, as if you're doing some AI kind of conversation. And then, so you in your own, you can make it, putting your own name there as if you are the one conversing with whoever is now using your program. You can put in your own name there in place of main. And then it goes on to say, how nice to meet you. Because when the person enters his own name, then it comes back to you speaking. You are now saying, how nice to meet you, Dave, or whoever it is that entered his name. And then you now say, I'm only a few days old. You can see the printf statement there. You can put your own age in that construct, the printf somewhere here. You can put your own age. So it displays your age. It's asking, how about you? How old are you? So it's kind of interactive. And then it prompts for the user to enter their age. And it's ready to receive it in the variable age. And then it goes on to print here, how lovely to learn of your age, okay? And then it goes on to take, I am only a program code. I reside on the memory, so that's about the address. You can make additions to that and just say, I'm a student of National Open University. I reside, wherever you reside. Put it into that line statement of printf. Include your address there. So that will make it print it out as required in the exercise, which we have come here to handle. And then interactively, it goes on to ask, where do you reside? Where do you reside? And then this scanf statement prompts for the user to enter an address. Okay? And then here, print out, wow, interesting stuff. And it goes on to say, from here, I speak a couple of languages, including C. On a new line now, it says, do you speak C language too? And expecting a response of yes or no. Expecting a response yes or no. And a scan statement here is prompting for a response to be saved in the variable name language. Language. And the variable name, the variable language is string. It's just one, whether it's Y or N, yes or no. And so it now goes to check using a switch statement, control structure. We'll be doing that right after this now. Switch statements using language as the input. In case of Y as your language input, you go ahead to say, oh, great, that's awesome. So in case the person answered yes to the question, do you speak C language too? The person says yes, for Y means yes. Then the output is, oh, great, that's awesome. You can see that right there. Oh, great, that's awesome. And then it breaks out of the switch statement. But in the case of an N, no, like you don't speak C language as well. It goes on to say, oh my, no worries then. And it breaks out and there's a default. If there is no case of yes or no, it goes and say, I'm sorry, I didn't quite get that. That's whatever inputs. So it's just the use of a switch statement. Please study and observe how these things are put together, how they manipulate, how they work, how they are written. Just in case you want to write any sample program of your own, you can come learn how they work between this code here and that of the simple calc here. Study the switch statements, study the name declarations, study the variable declarations and all of that. And then if you have any sample program to write, you can just borrow one or two codes from here, begin to construct yours. And then if at any point, I will definitely make these codes available in the platform. I'll be copying it out there for you to be able to extract and run on your own platform. I recommend you use this particular platform I'm using, even though it's a little on the high profile side, but begin to get used to it. It's CXX Droid. So if you have any errors, any error at all it generates, you can't seem to get through with it, screenshot that error and make it available for me on the WhatsApp platform. I will look into it and respond what line to look into, what to correct. I'll just say a couple of things about that error and everyone can learn from it. So that is about this one here. Once again, I mentioned putting your own name, putting your own address, and that answers for the question which we came here to handle. So let's quickly see how this program executes. So there it goes. Hello there. My name is Maine. What's yours? So let's say AI is interacting with AI, and I put an answer here. My own name is Sub, like sub program. Hit and enter. He says, how nice to meet you, Sub. I'm only a few days old, of course. How about you? How old are you? I just go in there to say 3. This is expecting age, and age has been declared as an integer. So if I put in anything besides an integer, it's going to flag an error. How old are you is declared. The variable age there is declared as an integer with 3 spaces. So I put this one here, and it says, how lovely to learn of your age. It's not as if it does anything with my age, but at least it's been interactive. I'm only a program code. I reside on the memory, so you can put in your address in this place. Let it print it up back to you that I reside on so-so street. You can put it, I'm only a student of National Open University. I reside, blah, 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 blah. How about you? Where do you reside? And it goes to say, this one says you reside in the memory. I can say I reside in the storage for the sake of this AI interaction, storage. And then it says, wow, interesting stuff. And it goes on to say, I speak a couple of languages, including C. Do you speak C language too? Enter Y or N. So in the case of Y, as yes, Oh, great, that's awesome. And then the program ends there. So if we're good to go back, oh, pardon me for this. If we were to go back and execute with a no at that last line, let's see what it would do. My name is sub here. H3 here. Reside storage. Trust and study, speak language. Okay, let's say I put a no here, N. It goes to say, oh my, no worries then. So you can see the switch statement took into consideration what was imputed, whether Y or N, and gave me an output for that. Please study the switch statement very, very well. And then the program finishes there. But let's go one more time and see if we can generate an error from that last response, yes or no. We can generate an error, see what comes out of it. So once again, sub here, 3 here, reside in storage. Okay. Okay, so in the place of yes or no, I put in T. And it says, I'm sorry, I didn't quite get that. So you can see the switch statement does a quite interactive job there. So please take note of this, study very well. It will just open your mind up to sample programming, and you begin to get your hands on C gradually. All right, great to be back from that little outing to the C environment. And be sure to try your hands on those modifications to fit up with these exercises. It gets better and better. Next, we'll be talking about control structures. Of course, I'm sure you've seen one or two of these in the course of the environment. You mentioned this is a control structure. We'll talk more about it later. And from the name control structures, these are program modules, functions, small functions on their own, which do a little bit of controlling of the execution of the program. Controlling, they transfer control here and there. They make decisions based on some conditions which the user, the programmer, may have set. And let me put it in retrospect. The control structure is such a program function that takes a test, a condition, into tests, and based on the output of that condition being tested, it diverts or directs control as programmed, as specified. So a test is there, and then checked with whatever inputs necessary, and then the output must have been stated with every input condition therein. So it's all just instructions for the computer to obey, but directed here and there based on whatever output from the conditions set already. And we will begin to see more words that have been reserved. Talking about keywords now, system-defined reserved words like while, like loop, like do, like for. And we've seen switch earlier on, even if statements. So there are a couple of these control structures. These names I just called for you. Each of them represents one or two control structures. I'll mention them quickly, one after the other, before we begin to look into each of them. First off here is the while loop. The while loop. Look at it there. While loop. We'll look at the short note on it and look at what the construct, the structure of it is like. This other one here is the do while loop. Do while loop. It's a little different from the while, but kind of close. Do while loop. We also have this one here, the for loop. For loop. See that there? And then there is the if statement. The if statement, that's about the fourth one there. And then there's also the if else. If else statement, that's about the fifth control structure there. And then there is this one here, break and continue. Break and continue. That's about the sixth one there. And we also have this one, which we are a little familiar with already, switch statements. Switch statement, it makes use of switch case and break. Switch statement. Then that's about the 7th one. We also have the go-to statement. The go-to statement is about the 8th one there, and that ends it being outlined, being itemized. All of the control structures, 8 of them. So in case you're asked how many control structures, there are 8 of them in number. Be sure to make it as simple as possible so you can remember all of them if the occasion calls for it. So beginning with the while loop. While loop. Don't forget we said there was a condition to be tested and outputs are stated with the actions to follow for each output. So the while loop. While loop. Look at this. Let's look here. Everything we need to know about the while loop is contained within in here. While statements begins with the word while, and then it has a variable inside the parentheses. Don't forget we say it's a function of its own. So it follows with how the main function is written. The name, the parentheses, and then the braces. The name, the parentheses, and the braces. Inside the parentheses, it can have some data that it will use as its own inputs. Okay? So while count is less than 6, that is the condition there, inside the parentheses. Count. Count itself is a variable that has been declared earlier and given a value, as you can see in this line. Count is initialized as 0. And before that, we saw that count was declared as an integer. Int count. Integer count. So a variable a variable declared as an integer with the name count. And on this line, it was initialized to have the value of 0 on this second line here. Oh, sorry about that. Okay, second line, it has the value of 0, a variable. And then the third line, it was used now. While count is less than 6, so beginning from that initial value of 0, and for every number that count represents that is less than 6, so it will go from 0 to 1 to 2 to 3 up to less than 6. That's where 5 is about the last number less than 6. 6 itself is not less than 6. So whatever it does in this testing, it will do for 0, for 1, for 2, for 3, for 4, and for 5. And that's about 6 digits already. And so what is it supposed to do on each of these counts? For while the number counts, the variable count is less than 6, it's supposed to do everything in this brace. And what does it say to do? Print the value of count. You see that? So for each of these counts from 0 to 5, it will execute a print statement, each one at a time. Print the value of count is, so it will just output that. The value of count is %d, new line, and then the variable count. So each time the number of count is encountered, it will print that number. So for the first number, 0, it will check. 0 less than 6, it is true. Then it will perform that thing inside the brace, which is the print statement, and it will print it as 0. The value of count is 0. And the next line after that, count equals count plus 1. Now that's like a counter, an incrementer, something that keeps the value of that variable count going up. This is where I said variable values do not remain static. They can change. So the variable count, initially 0, is now equal to 0 plus 1. And the new value of 0 plus 1 is 1, saved again in that placeholder count. So count now has a new value, 1. And then it goes back again to check that new value of 1. Is 1 less than 6? Yes. It goes again to print the value of count is 1. And it comes to the next line, 1 equals 1 plus 1, and that's 2. And it goes again, is 2 less than 6? Yes. It goes again to print the value of count is 2. And it does that for while count is less than 6. By the time it gets to count is 5. Is 5 less than 6? Yes. It goes again to print the value of count is 5. When it goes 5 equals 5 plus 1, 6. It goes up there, count less than 6. By the time it gets to 6 less than 6, no. It terminates the while statement. it just terminates. It just goes out of this final brace here. This final brace, the while brace, it just goes out of this line. After this line, it goes out. After the incremental, the brace after the incremental is the close of the while brace, and then it goes out. So if there's anything to execute outside the while statement, it goes on to execute it. If there's nothing else, then it goes on to end the whole program itself. So while only executes while the test condition remains true. For as long as that test remains true, it does everything inside the brace while statement there. Now, moving on, do while. Do while. Now, do while is a little different from while. Let's just see how it goes here. Be sure to read the notes that accompany these explanations I'm giving you. Be sure to read the notes. They explain better what I've just mentioned. The do while here has a do statement to begin with. So you can see on that line, a do statement, then an open brace. It says, do these things in the brace. And then the while comes afterwards. The while comes after the condition to be tested now. Do what? The value of I is now this. The value of I is now this. So this is what it's meant to do. Print out the value of I is now all that format and the new line and then the variable I. And then after that printing out, it tests I equals I plus 1. This is the incremental now. The increment. So it takes the value of I. Don't forget the value of I has initially been declared as 0. And then it's already declared as an integer value here. Initialized as 0. And so it takes the value of I is now I, which is 0 from the beginning. And then 0 equals 0 plus 1, 1. And then the while says I less than 5, yes. 0 less than 5, yes. 1 less than 5, it goes to print again. The value of I is now 1. 1 plus 1, 2. 2 less than 5, yes. The value of I is now 3. And it goes like that until 4. 4 less than 5, yes. And it goes to do again. The value of I is now 4. And then by the time it brings 4 to say 4 equals 4 plus 1, 5. While I less than 5 is 5 less than 5, no. So it terminates the do while statement. It terminates the do, automatically just walks out of that loop to do while. So understand what makes it different. The while statement has its own condition before initial and then the operation to be performed before the increment. But the do statement has its own operation to be performed first, the increment, and then the condition to be tested is last. These have their own specific kind of problems they are suited for. By the time you encounter a kind of a problem to solve, you will know which kind of control structure to use. They are best suited for different. Of course, you could even use the same 2, 3, or 4 types of control structures for the same solution. But each of them have their own uniqueness, and while this one is better suited for what problem than another one. So here, the for loop. The for loop, also closely related to the do while, it also gives a condition, yes, just as every control structure does. Where's that part of it? Here now. Okay. There is an integer declaration for the variable index, int index, and then the for statement begins from here. For index equals 0, that is the initialization, having declared the index already. Now index equals 0, semicolon, index less than 6, semicolon, then index equals to index plus 1. So everything from the initialization to the condition to be tested to the increment, they are all in the brackets, the parentheses, for the for statement in that one line. In that one line. Then the next line we go to an open brace, the body of the for statement now. So for a while, index begins from 0, and every value of index that is less than 6 while index increases by 1 per term, go ahead and print the value of the index is. So it keeps printing every incremental value of the index from 0 and then 1, and it prints again, the value of index is 1, and then it goes again, increments, the value of index is now 2, then until that condition of index less than 6 is undone, until that condition no longer is true. And of course, at index equals 5, it is still true. It will print the value of index is 5. But at index equals 6, it's no longer less than 6. It will terminate and just walk out of the false statement. So take note of these. We'll begin to see them in use in some program constructs, and then we get familiar with them. But this is just how this one operates. The false statements enclosing the initialization, the condition, and the increment in one line, and then the operation to be performed in a brace inside the next line. Okay, read the notes underneath it. It explains a lot better what we have just summarized. Yes, the if statement is next. If statement. The if statement is is such that it tests a value. It really doesn't follow with incremental. If doesn't really do incremental, although it could be manipulated. If rather we just check 1, 2, 3, maybe not 3. If something has to be incremental over a large range of values from 5 to 6, then the whiles and the do whiles and the fors. But if something is just between 1 and 2 options, then if comes in. 1 and 2 options. Now let's see how this if works here. This line. If, open bracket, data equals 2. If data is supposed to be a variable name, you can see earlier on, data was declared as an integer here, there. And then there's a false statement here. For data equals 0, the initialization, and then data less than, what's that now? Data less than 10, that is the condition. And data equals data plus 1, that is the increment. Then you see the open brace for the for statement. And inside that open brace of the for function, you see if. So the for statement is checking values of data from 0 to 9. 9 is less than 10, from 0 to 9. And then it says, if data equals to 2, so amongst all that range of 0 to 9, when data is equal to 2, what should it do? Print data is now equal to 2. Because that's the value of data at that point. I'm sure for all those other values of data, it may not perform anything because it's not stated here that it should perform anything. But for the condition that data equals to 2, when data specifically becomes 2, print that line, data is now equal to then 2. And then it continues to check data incrementing 3, nothing is said to be performed. It goes again 4, nothing is said to be performed. Then the if statement that follows here says if data, this line here, if data is less than 5, if data is less than 5, there's another if statement there, and it seems to contradict the one above, because the one above says if data equals 2, just that condition of 2. But in this one, if data is less than 5, so everything from 0, 1, 2, 3, 4, it goes ahead to print data is now this, which is less than 5. Look at that. So I'm sure from 0, it would obey this one here by printing data is now 0, which is less than 5. When it first check data to be equal to 0, excuse me, let me make this a little wider. Okay. So when it first check data equals 0, it will obey this one somewhere in between. It will obey this and say data is now 0, which is less than 5, and then to go again and check other things. At 0, data equals to 1, it will obey this one again. Data is now 1, which is less than 5. And then it goes on incrementing. When data is strictly equals to 2, then it comes to obey this one here. It says data is now equal to 2, yet it will still obey this one because 2 is still less than 5. And it's on print. So it will have a double print statement for that condition of data equals 2. You will first print this. Data is now equal to 2. And then it will come again and say data is now equal to 2, which is less than 5. We will obey these two statements for that condition of data equals to 2. Then it will continue. Data equals to 3. Is there anything said to be done? Data equals to 4. Okay, there's an else statement here. Else means every other value of data besides the one stated in the if statement. So for 0, for 1, 2 has been mentioned here. Everything less than 5 has been mentioned here. And everything else. So at every point in time under this condition of 4, data less than 10, it will do at least something on this else line. It will do something on this else line. Print F. Data is now this, which is greater than 4. Okay, so for everything as from 5, if data is not 2, data is not less than 5, it will do everything which is above 5 to print. So this is also a good manipulation between for statement and if statement. And it will be wise for us to extract this, take it to our environment, and then put it to run and see how it works. Very interesting setup here. Whatever errors you encounter, be sure to communicate me on the platform. I'll be there to respond and give you a headway with it. Take note of the comments here, end of the loop. So that's the if statement. They're just checking through a set of data to give some conditions and then operations to perform. Then there is the if else. If else. This right here above is not the particular if else. This is just if statement. An if statement can come 1, 2, 3. Look at this one here. There was one if here, then another one here, and then the last part of it, which is like the default of the switch, is always the else. But in the else if statement or the if else statement, what makes it different? Let's read through this line. Let's just read through. The second if is similar to the first, which with the addition of a new reserved word, the else, following the first print statement. This simply says that if the expression in the parenthesis value evaluates as true, the first expression is executed. Otherwise, the expression following the else is executed. Now, what does this mean? In the if-else statements, not more than 2 things are checked. The first condition in the if statement is checked, and if it is true, the operation or the instructions stated therein will be performed, like here. If the first line of if is true, then everything here will be performed. So in the if-else, it does not have a provision for a second if. Rather, it will just go with an else, this line. So in the if-else statement, there's only if, the instruction, and then else. And that is only to check 2 sides of a condition. If data is less than 5, do this. Else, do that. If data is less than 5, then do this. So in this first line, you say, let's just bring it to this place now. Here, if data is less than 5, perform everything on this line. Else, perform everything on this line. So everything from here, from this line downwards, is more like an if-else statement. It only gives one line of if and then the else part of it, and that's all. But in the if statement, there could be multiple ifs. Multiple ifs that ends with an else exactly. So that's just the difference between the if statement and the if-else statement. So now we have the break and continue. Break and continue. This one just helps to jump out of any portion of the program. In case you are in a loop, and something seems to be running continuously, the word break can just help you to jump out, and then it transfers you to where there is the word continue to pick up from there. So let's see the use of it here. For xx equals 5, xx is less than 15, xs equals xs plus 1. That's the first statement that has the initialization, the condition, and the increments, then the open brace, and we see the if statement inside the first statement. If xs is equal to 8 there, and then it breaks. If it is equal to 8. So whatever it is we are doing from 5 to 14, 14 is less than 15. Whatever we're doing for 5 to 14, it will not be done if x is equal to 8. It will skip that operation. If x is equal to 8, it will just skip. It may continue on 9 and so on. But because this has been set to a break, it will skip. And what is it supposed to do? Print in the break loop, xs is now at this point where x is 8. It will just break and print this. And then for xs 5 less than 15, incrementing, if xx is equal to 8, continue. Do you see that? So it breaks at 8 there, and it continues again at 8, the way this program was written. In some other program construct, it could break away from maybe 8 and continue at 10. So whatever line of instruction you have given to the whole sequence from 5 to 14, it will just skip at maybe 8 through 9, continue at 10. So that's the job of the break continue. The break continue. So please go ahead to extract this and run it in your program environment. Be sure to communicate any errors. And the way I'm seeing most of these programs written in this manual, do not forget to include your include statements. Many of them do not have the include there, so don't forget. And the main don't have their ints with them. These are just for text purposes. They just want to show us the important thing, the for and the if and all. But as a programmer, there are some things they have left out. If you copy this straight to your compiler environment, it will not run. So don't forget your include statement. Don't forget your main function with the ints, and then check a couple of other things before you begin to execute. Be sure to read the notes that follow. They shed more light on all of this. Yes, switch statements. Switch statements here. We have seen the job of this switch statements, and we are quite familiar with it by now. We saw it in the simple calc, and we saw it in the name address display. And so switch here, the input for switch is this truck. The input is the truck. Switch truck. Already truck has been declared as an integer earlier. And then a for statement with the truck. Truck equals to 3. Truck is less than 13. Truck equals truck plus 1. So something has to do with the count of the truck. We're counting the truck. So we're switching now. Truck is the input, and the switch statement. Case 3, if truck is number 3, which is the first in our for statement. Remember? First in our for statement. So when truck is 3, print the value is 3. Okay? And break. Don't forget the switch case break. As long as you're satisfied, whichever is the option in the switch statement, you just break out of it. And in the case of truck equals 4, print the value is 4. In the case of 5, go ahead and do, and it continues like that. So study how this switch case break works, and of course when you see it in the sample programs we have earlier, you get better understanding of it. And so we also have the go-to statement. Please be sure to read these notes. They definitely shed more light. Go-to statement, this just jumps to anywhere in the program. If the program is executing to a point and then you introduce a go-to statement, you must end it with the line number that you want to transfer to, the line number that you want to jump to, and then the the control is transferred from that point where you encounter the go-to statement, the point where you introduced it. Maybe on line 15, you now put a go-to 45. Be executing something and says, okay, at this point, this is equal to this, and go to 45. It just jumps from 16, 17, it skips all of that and goes to 45. And there is nothing on 45 that says, this is where I am. There's no other statement that will say, yes, continue, or yes, join me here. No. Just that go-to statement, and then 45. On that 45, okay, some other time, you could use an identifier. It's not only just the line number. So an identifier, you could use, you say, go to procedure. Procedure. The procedure itself is a name that you have reserved for a particular line. So at the point you just use go to procedure. The control will look through the program codes you have written for the word procedure. There must be a place you have named, a line that you have named as procedure with the colon in front of it. And so it will just jump to that line and continue execution from there. Look through at this sample code in this environment here. Unfortunately, I'm not able to highlight like I've been doing, but I hope this is clear enough we can see. Look at okay, the main with the open brace, the int dog, go to real starts, go to real underscore starts. From that point, go to real on. There is a place in this whole code that is named real underscore start. If you go through down, look, there's somewhere called real underscore start. Aha, it's just after this program comments. Aha, just where this image is showing real underscore start. So from that go-to statement, it comes to this real start and continues to execute. And then some other place you will see another go-to statement. So they used identifiers here as their identity to transfer control rather than just using line numbers. Just below this printf, this first printf here, there is a go-to stop it with a semicolon. And stop it here refers to another place in this program that has some instructions. Towards the last line here, somewhere the last, very last line here, you can see stop it, printf. This is the last line of the mess. So study this sample environment quite well. You see how the go-to jumps around in the program and the transfers control here and there. And be sure to read the notes that follow. They definitely will shed more lights on the control structures. So here we are, we encounter another set of exercises, which I still recommend that we always go through them. I think I have something prepared to get us to understand this better. This one says, write a program that writes your name on the monitor 10 times. Write the program 3 times, once with each looping method. With each looping method. There is a 4. Okay, from these control structures, did I mention that some of them are actually called loops? Loops. Oh, their names are there. The while loop. The while loop. The do while is a loop. Those things that keep going around. Iteration. They check, they come back, they check, they come back. And then the for loop. The if statement is not a loop. It just checks one condition is true, it executes. Otherwise, it does another thing. So the 3 loops are the while, do while, and for. And so in this exercise, we're asked to write, wow, very interesting stuff here. Write a program that writes your name on the monitor 10 times. Then write this program 3 times, once with each looping method. So with the while loop, the do while loop, and the for loop, use the 3 loops to write your name on the monitor 10 times. And the second part of this is write a program that counts from 1 to 10, prints the value on a separate line for each. I think we saw some of that in some sample codes. To print the number per time. You check the number, increment, and print it out. So there's going to be a print statement that prints out the variable name that is being incremented already. Okay, so separate line for each, and includes a message of your choice when the count is 3, and a different message when the count is 7. Just like when count is equal to 2, it prints something specifically, and it does not print that on other numbers. So I think I have something prepared for this, so we can see how this performs. We will go quickly now into the environment and see how I think I put something and I added a couple of things to make this more interactive, but we'll be able to play around with it, see the basic things and a couple of other things that present themselves to us. And when we come back, we'll be discussing library functions. All right, so here we are at the C environment to tackle the exercise before us. A couple of those have been combined into this one sample program. We'll be seeing each of those requirements play out in this program. We've done well enough to put a couple of program comments to explain what each line, each section, each segment is meant to achieve. Okay, so we have our include statement, studio.h, not much to declare up there. Just the standard input is just enough for this simple program. And then the comment there, a combined C program to accept a random username, print the same along with an embedded system name 10 times using the 3 different loops, while also showing the numbering and specific messages at specified number lines. So I think that captures everything those 2 exercises are requiring of us. You start off with the int main, the main function. Variable declaration there, integer I equals to 1. That I stands for our counter, which we'll be incrementing at different times for the loops. And then we have an array declaration, name, and the character data type, 10 spaces. That should cater for the name of the user. Whichever user is utilizing the program will be required to put in their name. Okay, so at this first section here, line 11, we have a print out the system embedded or administrator name. So there's a system name which is embedded in it already, like the programmer's name or the administrator name, the system name is embedded. And then there's also a prompt for a username, whoever is running the program at whatever time. So the print statement there, hello there, my name is Rayburn. You can call me Ray. What's yours? So that's an output statement with the name Rayburn. I think that answers for printing out the name. But of course, that's not 10 times yet. So a prompt there asking for the username to be taken into the array declared in the declaration segment above. And then line 15 here, print the username with a progressive line number using the for loop, and then show a loop type comment on each line. So this next line uses a for loop to print the username, the name of the user, whoever is using that program at that time, having received the name of that user in the variable name. So we're set to print it out, and 10 times, of course. You can study the printout section there. Don't forget there's a for loop in there, so the for loop will cater for the 10 times over. So printf, your name is %s, %d, and then time, I, name I. So we have there for I equals to 2, I less than 11, and I plus plus. That is just a modernized way to put in the for statements. Usually the for statement has the initialization, the test condition, and then the incrementing. So all still involved in that for statement. I equals to 2 initialization, I less than 11 is the condition to be tested, and I plus plus there is just the short form for I equals I plus 1. Incremental. It's just a short form and the compiler recognizes it. So then the open brace. So for that for statement, while I starts from 2, do not forget we we have printed the first one already. The first print F is a first number 1 print. So we take it from 2 now. These things just allow for you to be able to manipulate. You know your number count you need. So you know what you should do with the for and the loops and all those other numberings to attain what you desire. You need 10, you've printed 1, you go from 2 to 11 or however you program it. Just make sure you're putting parameters and delimiters to get you what you require. So the print statement there, for your name is that, 1 time that. So I put in as a line number first, a line number 1, which will take that line number from the counter I, and then it goes to say, your name is, then it prints the name, and then it prints the number again, 1 time. So let me read what you will see likely on the screen. 1, then a tab space. Your name is name, whatever name that's entered, then comma space 1 time. So I'm using that to put up the line numbering and then the comments and then the name. The line numbering, the comment. I think I should just quickly execute this so we have a clearer picture. Then I'll come back to explain through what it does. There it is. Hello, my name is Rayborn. You can call me Ray. What's your name? So let's just say the programmer puts in the name May. May. And 1 button, enter. See what it does. A line number 1 with a tab that says your name is May, 1 time. Line number 2. So the first statement begins from the line number 2. For your name is May, 2 times. 3. For your name is May, 3 times. It does this 10 times over with just 1 line construct that we have set in the first statement. That 1 line construct and then the numbers that we arranged in the first statement, I beginning from 2, I less than 11, and I incremental. It caters for all of this reprinting. For your name is May, 2 times, 3 times, 4 times, 5 times, up to 10 times. So this shows that we have done our line numbering. We printed 1 to 10. We put in a comment on each line, and we printed the name 10 times. Mind you, this name here is the name of the user, and we're using the for loop to achieve this. We will do likewise with the while loop and with the do while loop. So here's the for loop getting its stuff done 10 times over. So let's go back to the programs segment. You can see in the for statement, for I equals 2, I less than 11, I plus plus, the print statement. So the print in the for caters for from 2. For your name is, but look at this. For your name is, so it starts from the line number 2. But here, the line number 1 doesn't have that. Your name is, although it has a line number 1, then tab. So the first line says, your name is May. Your name is May. Then beginning from 2, it now goes to say, for your name is. So I intentionally included that to show that we're using the for loop for this. And everything in this is just between the for loop, between here and here, between here and here. And so everything here is printed 9 times additional to this one to make it 10. And that's why we had to use these numbers the way we use them. Beginning from 2 and then less than 11, which is of course 10. And then the incremental. So 4 there takes care of printing that 10 times over. We go on to the next one. Print the administrator name. This time around, we're not printing the username, but the administrator, the system embedded name now, which is the Ray. So we're going to be printing the system embedded name. Mind you, we initialized I again to be 1. Because I here has changed a couple of times from 1 to 2 and has gone up to 10. So if we were to bring in the value of I from this place, from this first statement, exactly to this place, it will carry the value of 10. So we need to reinitialize the counter I back to 1. So that's why I put in this comment here. Initialize, as a matter of fact, it should be reinitialize. reinitialize. I'll just make that correction here. Re, and then put an hyphen, put an I. Initialize the counter afresh. So I'll save that very quickly. Reinitialize the counter. Okay. So we have a print statement for the first line, the print statement, and that comment in the print statement there says, and my name is Ray. One time. Do not forget, it will actually give us a line number first. And that's what this %D does here. It will prompt for an input, something to be printed there before it starts with the and. There's a tab there. There's a tab in between whatever number is coming up here and then this and. There is this /T. So you will see the number and the space before this begins. And my name is Ray. This is embedded, not as imputed. And then it goes there one time. And so this II takes care of it. Mind you, we do not have a variable name that is being called for printing because the name is already embedded. So here we're using the while loop, and the while condition states that our I should be less than 10. We have done 1 already. We have done 1 here. This is the first printing, line 1. And so while I is less than 10, and the value of I from here is still 1, the test states, yes, it's less than 10. It increments it. Mind you, we have done the first one. So it goes ahead to increment it first to 2, and then does this. Prints, and then the new statement says, while my name is Ray. Mind you, the first line doesn't have a while, but this now has a while my name is Ray. And so from the second line down to the 10th line, we see that statement of the while loop carrying the comment, while my name is Ray. The line numbers, yes, before each statement, and then the line number again, counting the number of times, just as we saw it in the for loop. So let's quickly go to the execution and see how that looks. Here we have Ray and May. Hit enter. So we see the for there. This begins the while section of it. The second paragraph there. 1, and my name is Ray. So this is the system embedded name, the administrator name. My name is Ray 1 time. From the second line, while my name is Ray 2 times. And it continues with the proper line numbering and the statement, comments, the name printed 10 times. So that caters for that using the while loop. You can see it clearly in the comments, the while loop. So let's go back quickly and understand what the last part does. And so here, and then now print out the administrator name and the username combined. The administrator name and the username with line numbers using the do while. This is the third loop now. The do while loop, and show a loop type comments on each line. Now with additional comments on line 3 and line 7. Additional comments on line 3, line 7. So now we go back here and initialize our I to be 1. We don't want to bring in a value for I to be 10 or anything other than 1. So we reinitialize. Just make that correct again. Reinitialize. Now save that quickly. And now we're printing the first line here. So our names, just make some corrections to this. Our names are, because it's both names now. Our names are, save that. Our names are Ray, which is the system embedded name, and then the %S is calling for a variable to be printed there, and then %D is the line number time. So there's a %D here first, which goes at line 1, and then a tab, and so the statement goes, so our names are Ray, and this variable name now is printed right after the Ray. And so the name will be May, of course. So our names are Ray and May one time. And that's the first line. And so how does the do while help us to achieve this 10 times now? We've done the first one, and then we come with the do statements, has its open brace, and then we've done the first one, of course. So the next thing is to increment, to take it up to 2 before we do any other thing else. So take your I, being value of 1, I++, it goes to 2, and then it comes again with a print statement. This time, do while our names are Ray and May. May is required in here from this variable name as entered by the user. So there is a line number from this prompt here, beginning from 2, of course, taking that the I has been incremented here from 1 to 2, and then the 2 shows up here, line number 2, and then it goes to print this, do while our names are Ray and May 2 times. And these accounts for the variables that will be printed in those prompts. And then there's an if statement here within the do while. If I equals to 3, now this is where we put in the specific statements for specified line numbers. If there are no instructions to put in a specific statement for line 3 and line 7, we may not need this if. We may not need it. Okay? So now, if I is strictly equals to 3, this is how we pronounce this double equal to. Some other context or some other text, you just see them right, I equals to 3. But the reason why I particularly call it strictly equal to is because in a place like this, we call it I equals to 1. And so in a place like this, we should have a way to differentiate it. This is how it is written in the if construct. But there's a way we can particularly differentiate it. Let's know that, okay, this one stands for just equal to, and this one stands for strictly equal to. So based on my own convention, what works for me, I just call it I strictly equals to 3. And I understand what it means. So if I strictly equals to 3, the open brace, and for that line 3 there, we have this comment to be printed. Printf, don't get it twisted. Just that simple line. And it closes that. And then again, it tests another if statement. If I strictly equals to 7, what is to be done there? It says here, no strings attached. Just simple comments to show on those lines. Additional. Mind you, there are already comments on each of the lines, but additional comments now. And so that is done with the do section. And if that if is closed here, then the while now sets the condition afterwards. While I is less than 10. So it has done for the first one, the printing here. It has incremented and printed the second one, and then it checks. This I that was incremented here, is it equal to 3? If it is, do this. If it's not, check again, is it equal to 7? If it is, do this. If it's not, then check, is it less than 10? Yes, it is. It comes back here, it increments, and then goes this way again. And it uses the new value of I here to do the new line number, and then the 1 time, or the 3 time, or 4 time. And while it does this, it checks again. Is I equals to 3? If yes, it does this. Otherwise, it checks here, and it does this, and then it checks again, and it goes all over. You keep doing this while I remains less than 10. And on the condition that now I equals to 10, it terminates. Now we have to understand how and why we are able to set these conditions, less than, and all of this. We've done the first one here. Outside the do statements, we need 9 more to make it 10. So the only other way is to set I to be less than 10, and that is 9. So 9 is still a valid number less than 10. 10 itself is not valid. Otherwise, we could have said if I equals to 10, less than or equal to 10. But because we have taken one out of the do loop already, and the same thing we did for the other comments, we took the first one out, so we had to set the conditions less than the actual value we're looking for to cater for one less. And so that helps us to achieve it. There are definitely many other ways you can actually bring the first one into each of the loops. just that the statement may be a little different, or like we did our first statement different from the rest. Your statement could be the same all through. You could even use an if in between the loops to differentiate your first statement like we're doing here. If I strictly equal to 1, you have its own statement. Then if I is otherwise, within the 1 to 10, you do otherwise. There are ample number of ways to actually do this. But the important thing is the loop helps you to achieve that iteration. And so the do while there ends there, and then mind you, it just ends with a semicolon here. This is actually the closing brace for the do statement. From here up to this place, as you can see, it's been highlighted already. This, and then this while is highlighted here, and then the while statement. So terminates there, and then this now is a new line trying to work on something about the address. Of course, you can build on that, begin to put in your own address and begin to modify and add whatever things that you want to see printed on the screen. And always our last line, return 0, before the final closing brace of the main program. So this should help us understand so far, and looking at it one more time from the compiler screen, you see how it executes. The username is May. You hit enter and everything just comes out in one piece. You can see the first section 1 to 10. Your name is May 1 time, and for your name is May 2 up to 10 times. And then the second segment there, 1 and my name is Ray 1 time, 2 while my name is Ray 2 times up to 10 times. And then the third section there, 1, so our names are Ray and May 1 time. 2, do while our names are Ray and May 2 times. 3, do while our names are Ray and May 3 times, but don't get it twisted. That's the comment on line 3, additional comment. Mind you, I didn't put a tab, intentionally did not put a tab there. Intentionally, so that comment line can stand out. It can stand, and you can put anything in there just to make it interactive, conversational and all of that. And then 4 continues as normal. 5, 6, 7, and 7 goes with the additional statement. May not have to be the same with the initial additional statements. Here it says no strings attached. And then 8, 9, 10. And it terminates based on the condition we set in the do while. And then you see that last line. My address is, which can be anything from where you live to where you hope to live. Okay, so that explains all the requirements in those 2 exercises captioned in this sample code. You can just take time, go through this, study as well, see all the different parts and how they function, go through the question again so that you know if you're saddled with any of the question individually, you know what portion of this sample code to extract. You may not absolutely need everything on this. To extract this portion, and this is what will get you, okay, if it's just the name 10 times with the do while only, or with the for loop only, you know what part serves that purpose. So you get to understand gradually, you can manipulate and so on. So here, that does it for this. These codes will definitely be made available. Do well to extract and run on your own. Any errors, be sure to communicate. And practice beyond these we are doing here. Any questions, of course, we'll be glad to attend to those. So we'll get definitely quickly now. Let's get back to our text and begin to round off this particular unit. Right. Glad to have you back again from that compiler outing. And I tell you what, our knowledge of C programming languages gets better and better with every visit to the compiler environment. Yes, those exercises adequately dealt with there. And we'll continue to mention practice. Get your hands on the codes, and if there are any questions, be sure to mention. We're moving forward now as we gradually wind down. Library functions. Remember we mentioned about C language that every line of code belongs to a function in C programming language. A function is a complete package of codes, a complete segmentation, complete structure, just a brief a brief construct of codes, has a beginning and an end, is self-contained on its own, it can perform a specific task, and a couple of other things, attributes to functions. And so we'll be looking at library functions and, of course, other type of functions, particularly user-defined functions. So what are library functions? I'll liken it to what we discussed when we mentioned the include statements, that there are some pre-programmed operations, processes that C compiler has in store in a repository, and all we need to do is to call them, require them through accessing the folders where they reside. And that accessing is what the include statement does for us. They include and then mention the name of the file or directory, and then we have access to them. So a couple of those pre-programmed operations are library functions. They have been pre-programmed in C language. They are not basically part of your own code, whatever programmer code you're writing, but they're just there like a dictionary, a backup, a repository. And you can just make use of them anytime you so require. And so a couple of library functions we see as put in a table on this line here. You can see the function name and the type, the data type, all this mentioned down here. The function name and the data type. We have ABS, open parenthesis, close parenthesis, I. How do you know a function again? Remember we said the parenthesis is always attached, the name of the function and the brackets, open and close. Sometimes it may carry some things in within it. Those are the inputs to the functions. Yes, it's allowed. Do not forget we have something similar to this, arrays. Arrays make use of square brackets, so that's how you know the difference. Anything that has a name and carries a square brackets and possibly names a number within it, that's an array. We'll get to those further on in this course. But for functions, the name of the function, the parentheses, yes, most of the time there's a data type attached to functions. So like you see the int main, that's a function declaration. It has its parentheses open and close. So other type of library functions here, ABS, which stands for absolutes, like absolute value, is being pre-programmed to take a value which is represented with the I, and then it finds the absolute value of that value it's imputing. And the return data type is integer. There's the exponential, EXPD. There's FABS, FABS. There's a floor. There's POW, printf, or you can see our regular printf there. And printf belongs to the standard input-output file folder. So when you declare the standard input-output stdio.h, it makes printf and scanf available. You can see both printf and scanf are included as library functions here. You also see sqrt, that's square root. You see tan, that's tangent. You see pow, that's power. Other types like cos, cosine, sin, sin. Those belong to the math.h folder. And so when you include the math.h in the include statement, it makes these mathematical pre-programmed operations available for use in your programs. There's also the put char, P-U-T-C-H-A-R, put char, and then there's also the get char or get char. Get character, put character. It has to do with storage, backup storage. Those are it's a different folder where it resides, storage folder. I think it's also affiliated to the standard input output, get char, put char. And then there is to lower, to upper. So lower to upper, those seek to convert text from whatever case, if the text are lowercase, and then you call the function to upper, then it takes the lowercase letters and converts them to their corresponding uppercase. That's what to upper does. And then to lower takes uppercase letters and converts them to the corresponding lowercase. So it's more of a text manipulation function. And those will reside in a text pre-programmed folder. So all this just suggests pre-programmed operations that have been stored away somewhere. We only just need to access them, and we will return their outputs into the program and just move on. Be sure to read the notes that follow the library functions there to throw more light on what we just explained. And then moving on, functions. Functions. Here, it still relates to the library functions which we talked about earlier, only that these now are defined by the programmer. Functions, call them user-defined functions. They are not system-defined. User, they are, you could just have a name, call it formula, call it anything that speaks to what you want to perform, and you begin to put some operations, some tasks, some calculations, some manipulations around it that solves the problem that you are thinking, preconceived problem there, and the solution. So it's just user-defined. It's just you bringing up a name, putting some lines of instructions to be executed in line with what you are hoping to achieve each time that your name is called upon. So it could be coined together. It may not be just one word name. It could be anything you coined. It could be anything at all. Just be creative, be intuitive, and then come up with something. So it's basically you, the user, you, the programmer, defining a function. And it still goes by the usual rules of function declaration. You have to set the name, put in the parentheses, open and close, set the data type, which is to be returned, whether int boy, int score, int average, whatever name you just put the data type, put the name, put the parentheses. If there are things that it should take as inputs, declare them in the parentheses as well. So let's study this here to see how these were put to use here. Let's just study this section of the code and see what is being done there. Character is the data type there, lower to upper. Then the input to this function, character C1. Character C1. Mind you, even the inputs will have a data type, and it's very good. It's a good convention, a good practice if we state the data type of the function and the data type of the inputs. We call it parameters. The inputs that go into the function, which are particularly put in the parentheses. It's a good practice to put the data type. So you can see that comment line that says function declaration. So that line there is just declaring the function to say, recognize this as a function, lower to upper. You can see how that is coined together. The programmer knows what he wants to achieve with this. And each time he sees lower to upper, he understands what he's trying to do there. And it takes in a character C1. And then there's a declaration character C2. And then it goes on. C2 equals C1 is greater than or equal to A, and C1 is less than or equal to 2. And then what's that? That's 7 or greater than A plus C1 minus A. All of those lines of code there just seeking to perform what the programmer tends to do. What we are strictly looking at is just how to declare, how to use, how to put functions into play. So you see how they are declared, and you see how whatever operations you want to get done by that function comes in between there, and then you return your C2, which is now the output. Mind you, what you declared in the parentheses is what's coming in, what will be used in the function to generate whatever output. So C1 is coming in as a character, and you can see there that C1 is used greater than or equal to this and less than or equal to that. Yes, C1 is used, and then C2 was outputted. It was generated, it was derived from the function, and then it's put in the statement, return C2. So C2 happens to be the output now. There must always be a return from every function. C2 returned, and then the close brace for that. So let's go. So that function was declared right after the include statement. We have not started the main function yet. It was just declared outside. More like the library functions are declared in their directories wherever they are. They are not part of the main function here. All we do is the include to have access to where they are, to be able to use them. So we now are declaring functions, although on the same page of this compiler code environment, but outside the main program. Just write the function lower to upper. And then when we now begin the main, we can now call that name. We can now call that name lower to upper. It's as if we are accessing it where we have stored it, even though it's not somewhere far away. It's just having the same function as if it's a library function, stored away somewhere, but it's us defining it. It's just us saving it on the same page there. It's just not far away, but we still have to refer to it in our main program now if we must have it to run. So our main program starts there. You can see it begin here, and then the open brace, and then all other parameters, variables declared, character lower and upper. You can see that there. And then there's a printf statement here. Enter a lowercase character, and then there's scanf prompting for an input, %C character stored in the variable lower. This lower has been declared already here as a character. So when it comes in here as a character, it's stored away in this, which is already declared as a character already. And then we now we take this new variable upper here. Upper is now equal to this function lower to upper, imputing the value of lower. Can you see that? This function lower to upper, which we have already declared somewhere up here and defined whatever operations we want to achieve with that, we have clearly declared and defined it. Declared is that we call the name open, and define means we write all the instructions therein. So declared and defined, and then the value for which it will return has been already made clear. So now we call the function here, and its input lower, which comes from what was entered in here. And then whatever lower means goes into this function lower to upper. The output is stored in upper. So when it calls this function, it goes in here, performs whatever is required, and returns this C2 as our output and saves it here, upper. The C2 that is returned is now saved as upper in the main program. And then we have a print statement that says the uppercase equivalent is now upper. So this is just a code segment here that makes use of a function lower to upper, a user-defined function, which was already initially defined and declared up here, and we had to access it. So that's the whole idea of functions, user-defined functions. So be sure to read the notes. They definitely give more explanation, and we will move on now. Arrays are more like data declarations as well, and they make use of memory spaces to make allocations for data. Remember the concept of placeholder and contents. So arrays are like that. When we have a couple of characters put together, the likes of name, address, it's not a single character, a combination of characters that make a string. We are expecting to impute it from somewhere, and we don't just want it flying around. We want to have it saved together somewhere so that we can use it all at once. Name, for instance. We declare an array open. The name of the array, the space required, the space that will accommodate whatever it is we are looking to impute. And then there's always a data type. So looking here, data type int, and then the name of the array here, x, and see the square bracket, right? That is the open braces for the magnitude, the space to be allocated to that array. And here it states 100. So on the memory, an allocation of 100 spaces is now declared readily available for the variable x. 100 spaces for the variable x. It's not the same as just a variable having just one space. 100 spaces. No, it's no longer a single variable. It's now an array. We can liken it to a line of records. One line, one row has 100 columns. 100 columns, but one row. With this understanding, you can be sure that arrays also have rows and column declaration. We could have two-dimensional arrays. But what we are doing here, first of all, like this int x is a one-dimensional array, one row of 100 spaces allocated for whatever is coming. It could be short notes, write about yourself in a program now. Let's say a program is written for someone to fill a form, templates and everything. And so there's a portion of it that says, tell us a little bit about yourself. So an array of 100 spaces can be made available, and then it will be told to the person not more than, say, 30 words, 50 words. And this 100 could be made bigger, maybe 500, averaging that every word is about 5 letters. So not more than 100 words. So in the back end, an array of 500 spaces have been made available. Look at this next line. Character, data type, text, name, array, and then look at 2 numbers in the square brackets. 2 numbers, it suggests row and colon. Row and colon, multi-dimensional arrays, 2-dimensional array. So it's like an array that has 8 rows and 0 column, however number that means, but it just suggests row and columns. And then here is a floating type array. This floats allows for decimal points, and the array name is n, as we see here, and a space of 12, one-dimensional array of 12 spaces. Let's look at this note. We have 2 types of arrays, one-dimensional array and multi-dimensional array. Their declarations are similar, but that of multi-dimensional is a little more complex. Look at that. Data type, which is the int, char, float. The array name, I'm reading this line here now. Data type here. Array name, which is what we have seen, x, text, and n. Then expression 1. The expression 1 caters for the row magnitude. Then expression 2 caters for column magnitude. And even there could be up to expression n. It's just multi-dimensional. There are magnitudes upon magnitudes by which data can be represented in an array. Now, several typical multi-dimensional array definitions are shown below. Look at this, the typical ones. Floats, able, 50-50, that's a 2-dimensional array. 50 spaces in a row, 50 spaces in colon, made available for the array name able or table. So, table, permit me for that. Table, and then it's of a data type floats. So this can suggest an Excel sheet that is ready to have numbers imputed. Numbers. So you're going to be entering numbers in decimals, maybe 3 days. It doesn't state how many decimal points, but it makes provision for decimal numbers. 50 slots across the row, 50 slots across the column. So 50 by 50, that's about 2,500 cells. As an Excel sheet will allow. Another type there, character type page. Character type page, we have 24 by 80, 24 rows, 80 column. So this may just be something taken in grades. Since it's character type, single character, it's not as strings, but you can allow a couple of strings in each cell, name, address, all of that. So all that put together is what an array does. And we have seen array already in use in our visit to the compiler environment, where we have name declared in 10 spaces and a couple of those. We have seen them a couple of times being used. Yes, we have another exercise before us. Let's read through it and see if something we should visit the compiler environment for. Describe the array that is defined in each of the following statements. Okay, just describe. Just tell us what kind of array this is. So the first one here says character name 30. Character name 30. So it suggests a one-dimensional array of the name one-dimensional array of the name and data type character, or the character type array name 30 spaces, one-dimensional array 30 spaces. Then we have another one here. We have another one here. A float array, a one-dimensional floating point array named C, allocating 6 spaces. It's a one-dimensional here. Array name is C, allocated 6 spaces for floating point data. And then here we see the array name params. It's a 2-dimensional array. Array name params, data type integer, a 2-dimensional array allocating 5 and 5. 5 on row, 5 on column. So however you put it together, it really doesn't have a particular convention to naming it. Just be sure to touch each of those things you see. The params array name of data type integer is a 2-dimensional array allocating 5 rows, 5 columns. And that answers it. So for question 2, write an appropriate array definition for each of the following problems situation. Okay, this one here still doesn't require the programmer compiler environment. Let's just get to understand the English and speak some programmer language to it. Define a one-dimensional 12-element integer array called C. Okay, so maybe this now can help us answer the question 1 above. The way they had named this. A one-dimensional 12-element integer array called C. So if we were to follow this convention and name this one, we'll call it a one-dimensional 30-element character array called name. I think that works. That works. Go to the next one. Here, we'll call this one a one-dimensional array of 6 elements, floating points, 6-element floating point array called C. And then we follow that same convention for this one, params. So please stick to this descriptive convention to name whatever arrays given to you. So they said define one-dimensional array 12-element integer called C. Assign the values 1, 4, 7, 10 to the array elements. Okay, this may require a visit to the compiler environment to see how we assign values. And then the B part there says define a one-dimensional character array called points. A one-dimensional character array called points assign the string north, N-O-R-T-H, north, to the array elements and the string with a null character. Okay, so for question 2, A and B, we will be visiting the compiler environment to see how the array works there, and get familiar with assigning, do some manipulations. Like I always do, I like to add a couple of functionality to take us one step further than what is expected. But we always know where to draw the curtain on what is expected here and whatever else that we are doing ahead of what is required. All these things just get to solidify our knowledge and exposure to the language. So in a bit, we will be in the compiler environment again to see what we can make of these and what else can present itself to us. All right, here we are back again in the C language lab, and it's been interesting how we'll be going back and forth between the classroom and the lab just to get our hands on every little detail about C language. And every time we come in here, something appeals to us. We get to learn something new, something different. Yes, something skipped out of our memory. One of those times we had come to the lab, and just before it escapes again, let's quickly look into it. The program comments, we had two formats. I think I mentioned it earlier, but in the class. First format is the /**, which serves as the opening tag, and then the */ as the closing tag, as we see in line 1 here. So, and that works for one line only at a time. And then the other format is the /*. The /*. And the // works with multiple lines. As we can see in the second line there, multiple lines. Now, if we are to continue this line 2, as if it were part of the previous line, everything will be a comment, as you can see. Everything will continue as a comment. Why? Because of this multiple line comment tag here. But what makes us know which line the multiple line commenting stops is when we hit an enter button here. And so as we enter from wherever we want it to stop, the very next line becomes an executable line for the compiler to carry out. So the enter button is what terminates the multiple line program comments, as we witnessed with the //. So that being said, we're here to tackle arrays. Arrays, we have 2 of them. One states to assign values 147, call the array by the name C. The array name C, and assign the values to them. And the other one just says we should just have an array name and assign the letters NORTH and end with a null element, a null value. Now, very interestingly, every array must end with a null value. In other words, every last cell, every last element of an array must be empty. It mustn't be completely full. So if you're going to be assigning 10 values to an array, be sure to declare nothing more less than 11 elements, 11 cell locations. If it's a one-dimensional array, you declare array C11, the maximum it should hold should be 10 values. Always leave the last cell vacant. This is just to allow for memory usability, just so that the memory is not clogged up. The memory is not fully utilized and begins to slow down the speed of execution of the program. Peradventure, we have a program that has a couple of arrays declared, like a 10, 15, 20, even 100 arrays, and every array is fully loaded to its brim. Every 100 elements are completely full. Consequently, it will slow down the speed of the program execution. So it is highly recommended that every array declared must have its, at least, the last element empty. And this just allows for speed of the program execution. So this question particularly says, leave the last element empty. Include a null element for the north. So we see that solution here. And then the other solution talks about assigning values and increasing them progressively by 3. So 2 things there. Let's go by the simple one first. And in this one, I didn't put much of a program comments because it's just very simple. We'll be able to talk through it and understand what it's doing. So our include statement begins as usual, then the main function and open brace, and then here the statement says assigning string value north to an array. The string value north, N-O-R-T-H, to an array. Now we declare an array of the name points, character data type, 10 elements, 10 spaces now. And then this line is declaring the array and also assigning value to it. So you can see what we're doing here. We are assigning directly, putting in the values into the array. As we declare them, make allocation for them, we assign values to them directly. And then you see the values N-O-R-T-H, and then this represents the null element, the empty element. It's a null sequence. It's one of the escape sequences like new line, tab, and all of those. It's a null sequence. So it's used to represent an emptiness. And in this case, array, so the emptiness of a particular cell, a particular location, a particular element or placeholder in an array. So we assign 10 places for this array, and we filled up 1, 2, 3, 4, 5, and then the 6th one we intentionally left it empty, and the other remaining ones, of course, they are remaining empty. Ideally, this, if we're going to do a very ideal situation, we could have just made this to be 6, N-O-R-T-H 5, then the 6th one is the empty cell, 6. And so this is ideal. One space at least must be empty. And the reason why I had to bring it down, because let's not get used to wastage, memory wastage. If we had put in 10 there, and we know we only needed 5 and an empty set, an empty space 1, then what's the use keeping the remaining 4 in this array? The remaining 4 spaces can be useful for another array or another use entirely. So let's avoid wastage. These things are memory allocation resources, the computer resources. We must avoid wastage. So ideally, 6 spaces filled with NORTH and an empty cell. So we go this line, the counter declaration and initialization on the same line. The int I declared, the counter I declares as an integer and initialized to be 0. And then there's a for statement that puts in the initialization again. So on this line, we may actually just leave out the initialization. We may, because again, it was done in here. The initialization was done again. So let's say this line only is for declaration. The counter variable declaration, integer I. And then in this for statement, the counter is now initialized to be 0. And then the condition is set to be less than 5. And then the incrementer I++. So the open brace there. And the print statement, which it is to carry out for while the condition I less than 5 remains true. What is it supposed to do? To print out, this is a prompt for a character value. It's supposed to print out a character. And where is the character coming from? From the point array. The point array. And the I here represents the place location in the array. The I represents the place location. Mind you, every array has its place location assigned as name square bracket number. Name square bracket number. And that number begins from 0. So the first place, the first position, the first placeholder of an array is always the array name square bracket 0. So let's assume this particular array points having 6 spaces allocated. It will begin with point 0, and that point 0 holds the value of n. Then point 1 holds the value of O. Point 2 holds the value of R. Point 3, now when I say point 3, I mean point square bracket open 3 square bracket close, holds the value of R, no 3, 3 holds the value of T. N is for 0, O is for 1, R is 2, T is for 3, and then point 4 here holds the value of H, and then point 5 holds the value of this empty contents here, 5, as you can see. So everything in here points I begins to change per time, beginning from I equals 0 and I less than 5, and then increments one after the other. So for every value from 0, 1, 2, 3, 4, less than 5, 4, 0, 1, 2, 3, 4, up to the 4th, and where that value is H, it prints every value. It prints every value, NOUN. On a new line, we have to put the new line escape sequence here, and then the tab is also stated here. So this, in a bit, we will see the outputs, and of course we have our return 0 for the main function. So let's go see what this executes like. There goes. So we see our tab helping us to bring it out, and our new line spacing it all out, NOUN. And then we have that space down there. There's actually a space after the H. It's part of the array but has no content in it. So we see that down there, NOUN. So this answers the question. Assign an array with the name points with the value NOUN and end it with a null value. So this answers that. And so let's go back. Sorry, pardon me for this. Let's go back and see the other question we talked about. Another array, which assigns values 1, 4, 7, progressively increasing the values by 3. So here in this particular array, it's not the usual conventional kind of assignments like we saw in the other array declaration. It's not usual conventional. We had to introduce another array to account for the incrementing, another array to bring in the values we are going to be incrementing by. You'll see that shortly, where I have a second array declaration D. It holds its own value assigned directly, but those values are not the value we are told to assign. We are told to assign 1, 4, 7, 9, but I had to make this other array to be an array of arithmetic progression in 3. Arithmetic progression of 3. I just assigned the values 3, 6, 9, and so on. So let's take it from the top now. Program comment here. C program to show one-dimensional 12-element array where the values increase by 3 progressively, beginning from 1. So that comment goes all the way there. We have our include statements. We have our main. And then here, the counter declaration. Now, I'm just trying to teach us the very essence of program comments here. It's very, very good if you have that practice and the habit to always put in a comment. Although, in some other climes, it will be taught that these program comments takes a lot of line spacing. So where you would have written a program with only 10 lines and you have to put 10 line spaces, it goes up to 20 lines. 20 lines. So the whole thing just consumes space in terms of lines, yes. But again, for beginners, it's a good practice to put in comments, because you yourself sometimes can come back to your own program and you just suddenly are looking for what you were trying to do here. So with those comments, it just comes back to memory. This was what you were trying to do. And the better you get at programming, then you can begin to leave out commenting, program commenting. As much as you are the one who wrote the program, you know what you were doing, and probably the name of the program itself will just appeal to you like, okay, this is what I was trying to do in this program. So you won't need much of a program comments per time. But in this case, we're still getting our hands on. So program comments, counter declaration. You see the counter declaration here where it's declaring the counter I as an integer. And then array C declaration with 12 elements stated. This is one of the tasks we were told to perform. Declare an array C with 12 elements. So this is the declaration of that array. Integer C, square bracket 12, and close with a semicolon. And so that's where the array is just declared. C12, and that's it. And the next line, the comment here says, array D declaration with an unknown number of elements stated. Take note, array C has a known number, 12 elements stated. But another array D, which I just introduced, has an unknown number. Now I'm trying to show us that sometimes we can have array declarations with an unknown number of elements, unknown number of memory allocations. It's not stated, but you can go ahead and use it. It will just make available as many spaces as possible. As much as you keep asking it to take, it will keep taking. It will never take more than you have used per time. So if you declare an array and you don't state the number of spaces, and you just ask it to use 5 spaces, it will take the 5 and leave a blank one at a time. If you ask it to use 2, 3 more spaces, it will take them and use them. It will never take more than is expected, more than it is in use at that time. So it's just another way to manipulate arrays. So I have an array here, not stated the number of elements, but initialized with 10 values. As you can see, 10 values initialized. This is where I brought in constant integer D. Now, constant there means the values are fixed. Constant integer D. Constant is not a data type. It's just like the data itself. Constant. We saw that when we were treating constants and variables. We used the word const to state that this particular identifier is a constant. So const integer D is an array with an unknown number of spaces, but initialized with 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. That's what, it's about 10 values there. 10. I'll explain why this has to be 10 as we go on. So we move on. The counter I initialization. We have declared them further here. It's I, and here we now initialize it as 0. And initial value I equals to 0. And then we take here array C, initialization of the first element. Mind you, mentioned that the first element of an array goes by the way it is written here, C square bracket 0 for the array C. So we are putting the first value inside the placeholder of array, the first array C. And so it goes a value of 1. And that's about the first thing we are told to assign, beginning from 1, then 4, then 7, and so on. So we have made sure the first placeholder of array C carries a value of 1 by doing this line. Good. And then next, display the value of the first element of the array C. Go ahead and print it, the tab, and then we format the printing of a double, just in case the value is a long one. Just in case the value is a very long precision digits, more significant figures, in millions or billions. The double would take and accommodate whatever number is put in there. And so it comes from C square bracket 0, the very first position of the array C. And now we have a loop here that will test between 1 to 10 for us. Between 1 to 10. Mind you, we have done the very first position, printing first position 1. 1. Right? We have printed the value of C0, which is 1. And now we need 9 others added to it. And 9 is only less than 10. So for I less than 10, for every value of I beginning from 0, which we have taken care of, less than 10. Mind you, when you have 9 from 1 to 9, and you add 0 to it, becomes 10. So we have done C0 first, and then every other thing from 1 to 9 makes it all become 10. But test the value of I, either from the counter I initialization, or from the counter I incremental. The counter I initialization came from here. Here. Counter I initialization. So from the very first value of I being 0, but testing it here. Is I less than 10? Either taking it from here, I is 0. So yes, it is less than 10. So it will do all as required in the while loop, or it takes the value of I from the counter I incremental, which comes further down here. Counter I incremental, I equals I plus 1. So whatever I is increased by 1, whatever new value of I, it comes back to test it again here. And if it holds true, it performs everything again. We're still within this open brace until this becomes false by the new value of I from here. So what is it supposed to do within the open brace, the while loop? We have our first value initialized again to be 1. Make sure that value 1 does not change. The value 1 of our C array does not change. And so we are looking to increase the values of the second element to the last element. Mind you, we had not assigned anything, but we want to bring in some things that will keep increasing the first element. We have it as 1 already, as 1. So increasing that first element 1 by the values of the array D. Are you watching? The first element 1. Now, so if we go to the second element, I will want to increase it by the value of the first array element D. It means 1 plus 3. And that will give us 4 for the second position of array C. That's what this line is talking about here. The next position of C here is C2. It takes the first position of C0. The next position here is C1. Mind you, the first position was C0, and we are giving that a value of 1. 1 as of here. And so the next value here is C1. C1. And so when we take C1, it takes back the value of C0, which is 1, plus D1 or D0. D0. The value of D0 is the first position in D, which is 3. So it takes 1 plus 3, and that gives us a 4. It keeps the 4 in here. And then it goes on to print it here. Print the Ci that you just worked upon, and that is 4. And then it takes the I being 1 now and increments it. I equals I plus 1. I becomes 2 here. It goes back to check it. Is it less than 10? Yes, it is. It enters here again. It picks on the C0, which remains 1. C0 remains 1. It picks on that value and then goes again. C0 now plus the next D value. The next D value is 6. So 1 plus 6, a new value for C2 becomes 7. And then it goes on to print it, 7. And then it takes the value of 2, I becomes 2 here, and increments it to become 3. And it checks again. And this continues to run on the condition that I is less than 10. So it runs about 9 times, adding every value of D to the first value of C. Every value of D continuously to the first value of C. And so it looks as if we are adding 1 plus 3 gets 4, 1 plus 6 we get 7, 1 plus 9 we get 10, 1 plus 12 we get 13, and so on. It keeps increasing by 3, the very first value compared to the previous value. The very next value compared to the previous value keeps increasing by 3. And so we're able to achieve an incremental from 1 increasing by 3, like an arithmetic progression where the first term is 1 and the common difference is 3. And so there goes the continuous incremental. And this only happens for 10 spaces. Mind you, we had declared our C array to be 12, and we had printed the first one to be 1, the first position to be 1, and then we add 9 more to it. It makes 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we add 10 more to it. This is 1, 2, 3, 4, 5, 6, 18 and 6, 7, 8, 9, and 10. So we add 10 more to the very first one that was printed, becomes 11. 11 values for the array C, and then leaving the 12th value empty. Empty. Mind you, in the other array we saw earlier, north, we had to use the null sequence, the /0, null sequence character. But in this case, we can as well just leave it empty, make it a space with we are not assigning any value to it. That's another way to declare a null location in an array. Just leave it empty. You know it's there. It was declared in the array declaration for 12 spaces, but you fill it up with 11 values. So definitely the 12th value is empty. It holds no value. If you're asked to now print in the whole 12, it will print in 11 for you. It will print out nothing for the 12th position. So that's just another way to leave it empty. So we've been able to achieve the incremental value of C array from 1 progressively by 3. Let's see how this runs in the execution now. Okay, so here we are with our tabs and our new lines. We can see 1, 4, 7, 10, 13, 16, 19, 22. All of these is just 1 added to the subsequent value of D. 1 added to the subsequent value of D until it gets to the very last value of D is 30. Added to the first value of C, 1, and makes 31. And then after that, nothing else prints. Mind you, there's nothing else in D. It stops there, yes, but there is still an extra space in C. There's still an extra space. And even if we allow that C should print everything, it's just going to come out empty. So this has helped us to achieve the task as assigned to us in that array exercise. Be sure again to get your hands on this. Study. Criticize yourself. Ask yourself, why is this like this? Look into it. Do some research. Ask questions. It keeps getting better and better with every visit in and out of here. So I'll see you again back in the class shortly. All right. It's good to be back again from another interactive, eye-opening session in the lab. And I tell you what, it gets better and better with every visit to the C environment. And so gradually we're winding down. We have just a couple of more, or just about the last rudimentary elements, C language, after which we'll be drawing the curtains on C programming language. So having taken care of that exercise already, we are moving forward. We're discussing pointers now. Pointers. And as the name implies, pointers, these are identifiers in themselves which have no value of their own. They do not carry their own value. Remember the description of placeholders and content. Yes, they are placeholders in themselves, but rather than carrying a value, an original value, they carry the address of another identifier. And that other identifier they carry may have an original value of its own. So eventually, the content of the original identifier will be the content of the address it is carrying. So let me put that in a better understanding. We have 3 identifiers, A1, A2, and A3. There are 3 identifiers, integer variables now. A1 doesn't have a value of its own, but it's carrying A2. In other words, A1 is equal to A2. So whatever A2 is That is what A1 is. A1 doesn't have an original content. So whatever A2 happens to be, that's what A1 will be. Now, A2 in itself may have an original value, original content, or may also have the address of another identifier. Let's assume A2 now is equal to A3, meaning that A2 itself does not have a content of its own, a value of its own. Rather, its content is the address of another identifier, A3. And now let's now conclude by saying A3 itself has a value of its own, an original value, integer value, assuming A3 is equal to 4. So A3 there is a variable that is equal to 4. It's not a pointer. It's just a variable, well-defined variable, an identifier that has a content of its own. That's A3. But A2, that is holding A3 as its content, is a pointer. And A1, that is holding A2 as its own content, is also a pointer. So A1 and A2 there, having no value of their own, but holding the addresses of other identifiers, are pointers. I think we're seeing something similar to that in one of our sample codes in this material. Usually it occurs in functions a lot. Aha, here it is. I'll quickly zoom in on that. We'll discuss about it and I'll show you how it works. Yes, up to this point. Good. So, in the function, this is the construct about user-defined functions. Remember when we discussed functions and then there was this function upper to lower that was defined by the programmer and then a couple of instructions put there before we entered into the main program. So every function of such must return a value, must have an output. So let's assume like this function here, lower to upper, has done all its manipulation operation and is to return C2, whatever C2 happens to be. It is to return this C2 as an output. And this C2 is supposed to go into the main program. Anytime we call this function, it will come out with an output saved in the variable C2. And so now in the main program, we go ahead and execute from main and everything goes on smoothly until we call the function here lower to upper. And while calling the function, it takes a variable lower as its own input, the same lower that came from here, that was entered into. It was prompted, please enter the lowercase character, yes. So lower goes in to this function, and then here the function runs and produces everything and it returns C2. So C2 coming out here is now received as upper. Upper equals to the function lower to upper, taking lower as its input. So everything that comes out of lower to upper is saved in upper. Upper itself does not have a value of its own. Upper does not have an original value. It is whatever is coming from C2. Whatever value C2 holds, that is what upper here will hold. So upper is a pointer to C2, the contents of C2. And the contents of C2 can change at any time depending on the contents of lower. So whatever content enters with lower, and we call the function lower to upper, the value of C2 will always change and will be brought back into the main function as upper. So upper is a pointer there. Pointers are used basically in functions, arrays. We see a couple of them where a variable is just used to capture a response from somewhere, not the original value, but the address of whatever value is supposed to represent. Let's just read through the notes very quickly. Simply stated, I read from there, a pointer is an address. Instead of being a variable, it is a pointer to variable stored somewhere in the address space of the program. It is always best to use an example to display a pointer. So this whole construct down here below, index, and then we see PT1, PT2, and then we see how index is initialized at 39, and then PT1 is equal to index. PT1 here is equal to index. PT1 does not have an original value of its own. Index is a variable that carries the value 39. So if PT1 is equal to index, that means PT1 holds the value that index itself holds. PT1 is a pointer. And then PT2 is equal to PT1. PT2 also doesn't have an original value. It's holding whatever PT1 is holding, and PT1 is holding whatever index is holding, and index is holding 39. So they are all pointing at each other. Let's read further here. This line now. The following two rules are very important when using pointers and must be thoroughly understood. A variable name with an ampersand in front of it defines the address of the variable and therefore points to the variable. So you must always see an ampersand like this one here. This right here in front of index. Good. This right here shows that PT1 is pointing to the variable index. The ampersand makes it clear that PT1 is pointing to that variable. So whatever the value of index is assigned to PT1. PT1 is a pointer. That ampersand makes it clear that it is. Okay, so you can therefore read, I'm reading from here now, you can therefore read line 6 as PT1 is assigned the value of the address of index. You see that? Now the second row here, a pointer with a star in front of it refers to the value of the variable pointed to by the pointer. Line 9 of the program can be read as the stored, that is the starred value of to which the pointer PT1 points is assigned to the value at 13. Now you can see why it is convenient to think of the asterisk as a star. It sort of sounds like the word store. So a close look at all of this again makes more sense. Read through the notes. Let's read through this part. I saw something very interesting here. Note that PU is a pointer to U and PV is a pointer to V. Now, U and V have been declared initially up here. You see U3, integer V, no particular value of its own, but they are declared variables. And so now PU is a pointer to U, PV is a pointer to V. Therefore, PU represents the address of U and PV represents the address of V. Pointers are often passed into functions as arguments. You see that? This allows data items within the calling portion of the program to be accessed by the function, altered within the function, and then returned to the calling portion of the program in altered form. We saw that earlier on with the function notation here. Yes, that was what happened here. Upper and then return C2. So it just goes to say the same thing. Let's read further from here now. Pointers can work with arrays and even functions because you can return a function using a pointer to the calling function. So very simple there. Pointers are just those bits of identifiers with no values of their own, but rather referring to the value held by another identifier. And there are two formats to that. Either you use the star or the ampersand. So a closer look at these codes and studying again and constant practice will make these things, will drive home the whole point. In conclusion, a good consistent practice, wow, you can never say this enough. A good consistent practice will help you improve and diversify your knowledge and skill on C. Also be encouraged to read further and deeper beyond this material. And so that's a conclusive point there for C programming language as guided by this material. In this unit, you have been given the introductory concept of C programming. Also, you have learned how to create C source file, concept of arrays, introduction, and the list goes on. So very, very agreeably coming to a very good place to close up. See this exercise here, tutor marked assignment. I think a couple of these questions have been repeated already. I see question 2 there, the definition of each of the following problem situations, talking about one-dimensional 12-element integer called C. Assign the values 1, 4, 7, 10. We have seen that earlier. And the B parts, one-dimensional character array called points, and assign the string north. We have also seen that, so we would not need to go to the program environment to look at what that looks like. The very first question there, it says, what do you understand by control structure? Define the standard format of 4 different control structures. We've seen plenty of them, about 8 of them. So you just do well to go back to them, study how they are written, the for statement, the do while statement, the while statement, the switch, the if else, and a whole lot of them. Just study how the constructs are and then master them. Be sure to have their parentheses written near them and then the open braces. Don't miss out the semicolons. They are all part of the formats, how they are written. As for understanding of control structures, I would simply put it as a self-sufficient function that accepts an input, tests a condition, and makes decision, then transfers control of program execution accordingly. I'll say that again. A control structure is a self-sufficient program function in any language now. Self-sufficient program function that accepts an input, that's talking about the initialization. When the counters are initialized, that's an accepting an input, tests a condition. There's always something to test. There, tests a condition and makes a decision to transfer control of the program execution accordingly. So when the condition is set to be true, it diverts the control this way. Otherwise, it goes that way, the way it has been pre-programmed. So that's what we mean by accordingly. You can study again and you can come up with your own definition, your own understanding. There is never a perfect sequence to all of this. Learning is just continuous. So with this, we have come to a very good place to draw the curtains on C language. And this is still not the end of this course yet. We still have other programming language, C++ right ahead of us. We'll be coming into that subsequently. A couple of other programming environments that we'll be visiting again and again. And then there's Java right after the C++. So the whole course, Computer Laboratory 2, is all about programming. And as we always do, we wish you the very best success wishes in this course this semester. Thank you.